we are live once again. Welcome to HaasTec 2020, day number 2.
Day number 2. Yeah, we started this one early. We're coming at you at 7 a.m. of course, but we got here at about 5 a.m. So if we look a little bit tired, that's the reason why.
But no excuses, here we are.
That's right, Glad to be here. Another day of showing off a whole bunch of cool machines.
Yeah, we've got a bunch of cool stuff. So we're out in the products area, which is about a half mile away from the demo room where we were yesterday. Ton of cool machines out here. We're gonna do 4 machines today, 4 more tomorrow.
Yeah, this is the area where our product specialists test machines, new upcoming machines, and also stuff like the tools for the Haas tooling site, things of that nature.
So today and Thursday, we're starting early, 7 a.m. Pacific, 10 Eastern. On Wednesday and Friday, we'll be back to the same schedule we were on yesterday. We'll start at 9 a.m. Pacific, and then our second live session will be at noon. But in between, we have a lot of cool stuff.
That's right. As we keep repeating, in between our 2 live sessions, we've got a couple hours of pre-recorded video content that most of you haven't seen out there. We were playing that yesterday. Had a lot of people watching that. We were glad you got to see that. Yeah, lots of cool stuff. Did a factory tour. Brian's got a tour of our sheet metal facility. Got cutting demos.
Tons of cutting demos. We've got some maintenance videos, some service videos. So just a ton of stuff. So we'll be playing that for a couple hours. Encourage you to watch that, and then for sure, make sure you come back at noon, or excuse me, 10 a.m.
Yeah, 10 a.m. today. So I just want to do a quick shout out. We got a bunch of people on the stream already. Looks like we were talking about, and Cam was asking what machines guys are running out there. Looks like we've got a Haas Mini Mill 2, UMC 750, VF3. Tanner Graff says he's got his VF3 and ST20Y running while he's watching this. That's great to hear. And then we also got a shout out from a school, Aaron Zarmecki from Wallingford, Connecticut at Lyman Hall High School. Says he and all the students are watching there, so that's great to hear. Thank you for joining us. So we got a quick plug for our promo, of course.
Let's do a quick shout out to the promo. So if you go on HaasCNC.com, you'll see the promo we're running right now. It's called Unlock the Savings, and we're running it for a while, but this week we have a little bit more for you.
That's right, we got an extra 5% on top of the already great discounts we've got. There's a wide variety of machines that we've got sales, almost every machine out there.
Just about every machine.
But that sale only lasts until Friday. So if you're looking at a machine, you're thinking about getting a machine, definitely take a look at that promo. It's worth getting in on it now.
Definitely. So you can either contact your salesperson at your local Haas factory outlet, or you don't even have to talk to anybody. Go on the website, go for the machine you're looking at, and do a build-in price. It'll give you the full price, including the current promo, and you don't have to talk to anybody.
Who wants to talk to anyone these days, right?
Exactly. Okay, so today we've got 4 machines. Like I said, this morning we're going to start with John Nelson. He and I are going to talk about the GM25 axis, which is right next to us, and then we're going to go around the corner and hit the VR8. Now at 10 a.m., you've got a couple machines.
That's right. At 10 a.m., we're going to start off with the VC400. It's kind of a combination of a VMC and our EC400 platform. And then after that, that's with Milton, of course. And then after that, Marcus and I are going to take a look at the EC500 50 taper. You do some serious hogging on that machine. So definitely check that out as well.
Yeah, you don't want to miss that one. We're doing some heavy cutting, and be back at 10 a.m. to watch that.
That's right.
Okay.
So I'm going to let you guys go. I'm going to head out this way.
You're going to exit
John, you want to come on here?
We're going to bring John Nelson in.
Hi, Brian.
Morning, John. You can get rid of the mask now.
Thank you.
I guess I should mention that we're all wearing masks at all times, except when we're on camera, obviously. So, okay. So today we're going to talk about the GM25 axis, and this is a 2-axis spindle head machine.
Yeah, so essentially the spindle is mounted on the 5th axis, which is B, and it tilts in the knuckle, and then that's all mounted on C, which rotates around the Z axis.
Right. Okay. Let's talk travel real quick, because as you can see, this is a really big machine. We've actually got 87.5 inches of Y travel and 145 inches of X travel.
Yes. Now the table is 144 in X and 72 in Y. That's just inside of the posts here. But the but we do have 87.5 inches of Y-axis travel, so that allows you to get your ram off the end of the table and tilt over to 90 degrees to come down and have a little more extra room to machine from the sides.
So when your tool's over 90, you've got plenty of room to get to all sides of the part.
Yeah, yeah. And the rotary axes are the C axis, which rotates about Z, is plus or minus 245. So you would have to wind up and then unwind. You could do a full 360 and more. Plus or minus 245 on C, plus or minus 120 on the B.
Okay, so one thing we really want to point out on this machine and the VR8, we'll talk about it again, is if you're interested in this machine, you really want to go on HaasCNC.com, go to the GM25AX page, and look at the machine layout drawing. It's more important than ever on these 5-axis machines to look at the work envelope. And John, I'll let you explain why.
Because the length of the tool holder and the length of your cutting tool, when that head rotates over 90 degrees, that now narrows your work envelope, right? So even though we have, 87.5 inches of y-axis travel, if you've got tool buildup, tool lengths 8-inch long, and you tilt that over and you need to machine from this side and rotate over and machine from this side, well, you've cut your work envelope down by the length of that tool times 2.
Gets a lot smaller.
So you really have to have a good idea of how long your tool holders need to be and how long your cutting tools need to be for your job before you can really start figuring out exactly if this machine is big enough for your work envelope. And it's a pretty big machine, so you shouldn't have too much trouble. This does become an issue when we get over to the smaller VR 8, 9, and 11.
Right, and we'll cover that in a little bit here.
Yeah.
And we'll also get into more, we're going to talk about some other things like some safe zones and things like that that are built into the software of this machine, and we'll get to that here in just a little bit. So the table, we talked about the table. This is an aluminum table.
Yeah, aluminum table, and 1 inch thick, bolted down to the base of the machine and cut to be flat on the machine itself after it's assembled. But we have optional steel tables. There's a steel Blanchard ground top table that's drilled and tapped. We have an inch version that's drilled and tapped half 13 on 4-inch centers, so it's an entire grid pattern. And then the metric version of that table is drilled and tapped M12 on 100 millimeter centers.
Okay.
So you can get either or.
Similar pattern, just metric or inch.
Yeah.
Now, one thing we're going to do, we're not doing a cutting demo, of course, but we are going to run the machine. John has a demo set up here.
Yeah, I'm going to go ahead and get started. I've got my large remote jog handle here. So I'll hit cycle start on this. This demo part that we have is an actual mold for the carbon fiber monocoque of a wind tunnel model. So this is a half-scale wind tunnel model of the monocoque of a Formula One car. Shout out to our friends at Fiberworks Composites in North Carolina for supplying that for us. They cut this mold, this actual piece, on the prototype version of this GM2
the very first
in
one
their
we made.
shop, and then were kind enough to send it to us.
Yep, we really appreciate that. So we did a couple of things for purposes of the video and for the demo. Normally, this machine would come with some vinyl curtains to keep the chips and coolant contained.
Yeah, they're 5-inch wide, 80 thousandths thick pieces of vinyl that are attached to a rod and hang across the front here, and another one across the back, and it keeps everything contained really nice. You just can't see what's going on inside the machine from a camera's point of view.
Make for a very bad video.
Yeah, make for a pretty lousy video.
And you segued right into my next segment by stepping in front of that when it was moving.
Oh yeah.
Sal, can you get in on here, please? Get on this bumper right here. So, explain how these bumpers work, if you would,
Previous
please.
versions of our routers and this particular machine used to have a light curtain. But anytime that the machine was running, I could see that I'm in no danger. I wasn't allowed to step in here. Now I can, because we have a physical bumper here.
Right.
So it's going to put the machine into a feed hold condition and stop the spindle if I run into this bumper here, if this touches anything.
Right. So let's talk about the machine itself. The spindle, which we see running, is a 20,000 RPM spindle.
Yeah, fantastic 20,000 RPM spindle. It's a 16 horsepower peak and 13.4 horsepower continuous. It's really terrific for trimming composite structures, doing finishing work on 3D surfaces, hole making for sure.
Right. This is not a machine or a spindle built for heavy material removal.
Yeah. It's not the same spindle combination that we put in our VFs. It's a 30 horsepower inline. It is not not that, but certainly capable of what it's designed for.
Yep.
It's an integral spindle design. The motor is directly coupled to the spindle, and it's really, really fast, getting up to full speed and back down to zero. So spindle acceleration, deceleration, very, very quick. It's grease pack lubrication. So if you're machining a material that can't get contaminated with oil, wood, exactly. So it's very good for that. And the spindle is liquid cooled. So there's a spindle cooler, spindle chiller that's mounted up here on the back, and it takes antifreeze, very similar to what you're using in your car. Yeah.
Okay. Some other standard features. It's got a 30 pocket tool changer, standard. It comes standard with probing, which is incredibly important on any 5-axis machine.
For sure. And the other thing it comes with is chip augers. Now, it doesn't come standard with a coolant kit. You can get a coolant kit, a tank, and pumps, but we do provide the augers. So if you're machining a material, wood or any other material, you can sweep the material off of the table down into the augers and then use the chip chutes for chip evacuation. Really, really nice setup.
Okay. And now there's some unique features software-wise. So that's the mechanical part of the machine.
Yeah.
There's some really unique features software-wise that you really wanted to talk about. And one of them especially is jogging this machine in certain modes.
Yeah. We do have vector jog mode, which allows you to, when the spindle, when B and or C are not zero, you can press V and then J on the
for vector jog.
On the exactly on the keyboard for vector jog, and then the handle jog button, and now you'll be able to jog. I'm going to feed hold it right there.
Okay.
I'm going to reset my program. Frank, if you can bring up the screen monitor there. So I'm going to press the key V and then J and now hand jog. And you can see that I've gotten into hand jog mode because the position screens, the X, Y, and Z positions are highlighted. Now I just grab the handle wheel and back away from my part, and you'll see that we're jogging in, actually in this case, 2 axes because C was at 0, but B is tilted, and so we're jogging in the Y and the Z.
John, can you do that again so we make sure Sal gets that on camera? Can you
vector jogging.
Vector jog one more time, make sure he gets it?
Yeah, absolutely. So here I'm jogging along the vector of the tool, in towards the part and away from the part. This is super important. If you're drilling a hole and you hear that awful crunching noise of your drill breaking and you have to hit emergency stop, this is how you're going to get that drill back out of your angled hole.
Or if the power goes out.
If the power goes out, exactly. Same thing, you go into recovery and then vector jog out.
Okay, cool. Cool feature.
Great feature for the 5-axis machine. Also, we have dynamic work offsets and tool center point control. Standard feature in this machine. We'll talk a little bit more about that. Also MRZP. So we have a special VPS template for finding the machine rotary 0 point, MRZP. If you can get a shot over here, there's a tooling ball mounted to the table. So we probe that tooling ball in a couple of different positions and then store the values in settings. And essentially what that does is tell the machine where the location of the center points of the rotary axes are inside of the machine envelope. We store those MRZP settings. The things that are really key for a 5-axis machine like this with the tilting head is the location of the center of C-axis rotation, the whole thing, and the center of spindle rotation, right? Those are mechanically assembled, and so there's gonna be some error, but for this machine to be accurate, there can be no error. So we measure that difference and compensate for it all the time. When you're jogging, when you're in cycle, it's always being compensated. The other piece of key information is what we call the pivot length of the machine, and that's from the center of B-axis rotation here to the face of the spindle. So once we know that and establish that with the MRZP, we use that pivot length and add the tool length offset to the tool, and now the machine knows exactly where the tip of that tool is all the time when I'm jogging, when I'm running a program.
Okay, and all of that also becomes important for another feature that's built into this machine, and we call it safe zones.
Safe zones. So Safe zones are essentially a set of travel limits that are built around permanent elements of the machine. We have travel limits set up for the table. We have travel limits set up for the tool changer and the tool changer arm. These are safe zone limits, really. We have another set for the entire spindle head. And on this machine, since we have these columns on the sides that create the bridge and are part of the gantry, we also have zones that define exactly where those are. Now, as those things move through the machine space and the rotaries tilt, the machine is keeping track of where everything is and will not let you run a tool into the tool changer, for example.
Right.
If you were to come straight up with the B axis rotated 90, moved over to the tool changer and then tried to whip C around, it wouldn't let you do that. If you had programmed it, if it happens in a G-code program, you're going to get an alarm, possible collision detected. And if you're in jog mode, it'll just stop jogging. You'll get to the end of the travel.
And actually, let's go ahead and show that. So
okay.
What John's explaining here is when you've got your tool straight down like a traditional VMC, you're limited in how far you can travel. So jog that down in Z if you would.
So I'm jogging straight down in Z with B and C at 0. And you can see I'm going to get down close to this table.
Okay.
And the safe zone prevents me from running that tool into the table. Now the cool thing here is I'm just going to back up about an inch. I am going to select the C axis. Rotate this around here and then B. I'm going to get my B up at 90 or so. And now you'll see that I'm allowed to go much farther down in Z.
And again, the machine knows where the spindle is, the spindle head, and you're limited, your jogging effectively stopped right there.
Yeah, exactly.
So, okay. So that's why the MRZP is so important, other than just knowing where the center points are. It also knows where the tip of the tool is and factors that in depending on what angle the rotary axes are at.
Now, there's two different VPS templates in the control. There's one to set the MRZP, and essentially the spindle probe touches off the tooling ball, rolls over to the side, touches it off, and says, okay, now I know where the rotaries are. There's another VPS template that you need to run when the machine is first set up in your shop, and that's to calibrate the safe zones. So essentially it's doing a very, very similar thing. It's probing that tooling ball because the tapped hole location in the table for that tooling ball is in a specific location.
Right.
The software in the machine knows where it is. So once we probe that ball, then it calibrates the actual travel limits of the safe zones in regard to, relative to that ball.
Relative to that,
and
right.
then those numbers are stored in the control. And so that process is two different processes, basically very, very similar thing, but it needs to be done twice. And we have VPS templates that make it super easy for the operator or the service technician who's setting up the machine to do that at installation and periodically through the machine's life.
Okay, great. Do we miss anything?
Let's see.
Now, one of the things we're going to talk about that both machines have is something called planar jogging, but I think the VR8 is better suited to show that.
We're going to talk about planar jogging on the VR8. I did want to mention a couple more things about safe zones. So the safe zones are around permanent elements of the machine, but there are elements that are not permanent. These splash guards are not part of the safe zone. So you could definitely run this tool. If I rotated that C around right there, I would run my tool into the splash guard. That is not protected. The other thing about the safe zones is safe zones are tool offset aware. So what we say in the manual, and essentially what that means is that it's reading the tool offset all the time and it knows where the tip of your tool is. But you got to remember, if you have your tool offset set for tool number 4 and you take tool number 4 out and you go, oh, this next job's going to run a different tool number 4 and here it is and it's longer,
the machine doesn't know
but you don't reset the offset, you're going to be in big trouble if you're trying to jog that thing around, because it's going to be reading the offset of the shorter tool. You've got a longer tool in, you can picture what's going to happen. So your offsets need to be correct. It's a good practice every time you put a new tool into the machine, set its tool length offset right away. Don't wait.
I was going to say that's good practice anyway.
Yeah, exactly.
Okay. Okay, anything else we missed on this one, or?
No, that's it.
I think we covered everything.
Yeah.
So let's head over. We're going to walk around to the VR8. So if you guys are ready, Frank, can you bring that, while we're walking around, you can see the mess of our cables and everything. You got the Haas Buyers Club up there?
Yeah.
So, John, you did a demo. You did a demo here on the VR8, and we're going to show that in just a couple of minutes. But part of the demo is you use tools from HaasTooling.com.
Yeah, absolutely.
So we've got a new program on HaasTooling.com, and we'll talk more about this Thursday, but I just want to talk about it real quick. It's called the Haas Tooling Buyers Club, and you can see it up on the screen. And if you're familiar with Harbor Freight, which who isn't, you get all the coupons and all the discounts. Yeah. This has got kind of a similar feel. If you sign up for Haas Buyers Club on HaasTooling.com, you'll get one of these every week. And you can see this week, if you buy some inserts, you get a shell mill body, or if you buy different inserts, you'll get a insert drill body. So just wanted to mention that. And Frank, you can come back to us now. Okay, we're on the VR8 now. A lot of you might remember that Haas used to have VR8, VR9, and VR11.
Yes.
This is a lot different.
It's a very different machine.
It's called
from
the
those
same thing, but
models. And I'll say right here at the top that if you have a VR8, your programs will not run on this machine. That VR8 was an A-axis mounted on a B-axis on the spindle head. This machine, like the GM25 axis, is a B-axis mounted on a C-axis. You can't just swap the axis letters and run that old program.
That will not
your
work.
post-processors for your old VR11 are not going to work with this machine.
And maybe can you jog the spindle head down a little bit so we can get a look at how the head is on these machines. So we've got a VR8, a VR9, and a VR11. They all have 40 inches of Y-axis travel. So the difference comes in X-axis. So this machine has 64 inches of X travel.
The VR8 64, the VR9 is 84, and the VR11 is 120 inches of X-axis travel. Other than that, they're basically the same machine. The Y is all 40 inches. The Z-axis has more travel than the VF series that these are based on. Those are 30-inch Z-axis machines, but to accommodate the 2-axis spindle head, we had to raise everything up. So we have 42.5 inches of Z-axis travel on this machine.
Right, and you can actually see if you have a VF, get this extra section of sheet metal enclosure here. That's that extra travel that John
we
just
basically
talked about.
raise the top end of the machine up on risers 8 inches and then accommodate everything with different parts.
I know I talked about this on the GM5 axis, but I want to talk about it again. Any 5-axis machine, you really need to be familiar with the machine layout drawing. So not just for these machines, but any machine, you go on HaasCNC.com, go to whatever machine model that you're looking at, and find the machine layout drawing. It's right underneath the hero image, and be familiar with the work envelope of the machine before you get started.
Yeah.
Okay, so let's talk about the spindle.
Yeah, so first off, the spindle head assembly on this machine has got the same configuration as the GM25 axis, right? So it's a C-axis mounted on the Z, C rotates about Z, and then a B-axis here tilting in the front, and the spindle is mounted on there. So that other machine was an HSK F63, which is basically a router tool holder. This machine is an HSK A63, very different, not interchangeable tool holders at all.
It sounds similar, but it's very different.
It looks the same, it sounds the same, it's not the same tool holder at all. So this takes the HSK A63 tool holders, and it's also a 20,000 RPM spindle, but it's got more horsepower than the spindle over there. So
and we'll see that when we go to the cutting demo.
Yes, exactly. That spindle was 16 horsepower peak. This one's more like 24 horsepower peak. It's got 20 horsepower continuous, like I said, 24 peak at 60 or 40% of the duty cycle. It also is grease pack lubricated, so you can use it on materials that can't get contaminated with oil.
Yep.
And it's also liquid cooled and has a spindle chiller mounted on the back of the machine.
Okay, so that's the spindle, standard features. Let's just go through them real quick. We have a 50 pocket tool changer standard on this machine.
Standard 50. It's the only one that's available on this machine. It comes with the coolant system, chip auger, and also the probing system. As we mentioned on these 5-axis machines, they all come included with the whips.
Right. And it also has a 95-gallon coolant tank.
Yeah.
Standard on this. Okay.
Like the GM2 5-axis, this thing's got all of the 5-axis software features added in that we talked about. There's dynamic work offsets and tool center point control. The VPS template for setting MRZP, machine rotary 0 point. Also VPS template for setting the safe zone. This machine has safe zones established
so that
as
all
well.
Works just like the GM 5-axis.
Just like the GM2 5-axis. There's a few less things to run into on this machine than on the GM, but yeah, it has the same feature there. It's got a feature coordinate system. So both of these machines have what we call the feature coordinate system, which is G268 code. G268, essentially, people may call it tilted plane or custom plane, but it allows you to define a plane of rotation based on where the B and C axes are positioned. So we have that feature coordinate system included in the software features. There's also vector jogging on this machine and planar jogging, which is a new feature that's available now on both of these machines, or not available, I mean it's incorporated on both of these machines.
Right. So maybe you can explain a little more about the tilted planes or the G268. Maybe we can jog the spindle head and kind of show everybody what you mean by that.
So the first thing I'm going to do is jog my B, get it somewhere out here, and then I will rotate my C around, get it to some compound angle like this. You can move over a little more in the work envelope so I don't run into travel limits. All right, so my head is now at, where am I at? B is 38 degrees and C is 43.9 degrees. I can use V and J and handle jog to go into vector jogging mode on this, to jog the tool, and I'll do that here. V, J, handle jog, and you can see that the head moves as it did before. Now, if I come back here and I press the P and J and now handle jog, this brings me into planar jogging mode. We have a new tab in current commands called plane. So in current commands, I come up here and move over to, to plane. So here we have the work offset, the current work offset, tool offset, and values for I, J, K, Q codes. Also, the origins in X, Y, and Z. We have a set of commands over here on the right. My head is tilted at the angle that I want to jog in. It's tilted to the plane that I want to jog in. That's how I should have said that a little better. So now I just have to press the F2 key, and that sets my I, J, and K, which defines the plane. So now the machine knows that I want to jog in that plane, and now I can select the P, J, and handle jog buttons.
That's vector.
Cancel. P, J, and handle jog. Now I'm in handle jog mode. I can select the Z axis, and I'm in vector jogging. Hopefully you can see that. It's jogging along the vector. But now I can select the X axis, and I'm actually moving along the X axis in this plane that I define.
So again, you have defined that plane, and now you're back jogging in traditional, at least on the machine, you're asking either X, Y, or Z, but the machine knows your plane is tilted at that angle.
Absolutely.
And it's jogging accordingly.
And what that really does for me, so I've got this plane here that's my XY plane, G17. I've tilted it up here. My cutting tool is here. Now I've set my plane for jogging mode, so now that I can jog Z like this, X like that, and Y like this. The great thing about that is it allows me to establish a 0 point in origin. So when I was here, I had a work offset that was the corner of my plane, right? There's my G54 was there. My new plane is over here. I can, with an X, Y, and Z of 0, my 0 point is still at the work coordinate, but I'm jogging in these axes like this. If I add an X, Y, and Z position move on my G268 line to get me to this corner, now this becomes my 0 point in my plane where the tools are like this.
In your newly defined plane.
Yes, and the great thing about this is if I have a workpiece that's already got an angle on it and I indicate or I find out where that plane is, now I can program machining features like drilling holes, doing arc, 2D arc, G2 or G3, circle interpolation,
right,
and cutter compensation. All of those things that used to be only for 2D in the G17 plane now work in these custom planes. So it simplifies programming, and also I have the ability to jog and move around, and I can actually manually machine some features in this plane using the X, Y, and Z jog keys and paying attention to the X, Y, and Z coordinates. If you look up here in the plane tab on the screen, hopefully Frank's got it up over there still, you can see my current coordinates in the feature coordinate system.
Cool. Okay. What else do we want to cover on the VR8 here before we get to the demo? I know we got a cool cutting demo, but
we talked about planar jogging. Oh, I wanted to mention setting 335. So
That's right.
For about a year now, we've had a new setting in Haas next generation controls called linear rapid mode. And essentially, it can be set 3 different ways. In a G00 rapid move, all the axes that are programmed to run in that command, to move in that command, in all Haas machines built since the beginning of time have been, all of the axes start traveling at their maximum speed towards the end point, and the axis with the shortest distance to travel stopped first, and the axis with the longest distance to travel continued. So you'd end up getting a dogleg rapid, right? The only way to make it start at one point and end at another and travel in a straight line was to program a G01, linear interpolation.
Right.
With the linear rapid mode, you can now set your machine to travel in a straight line. All the axes in that rapid position move will start at the same time and end at the same time.
So even if you've got X, Y, and Z
Yes.
all in that line.
All in that line, they'll travel in a straight diagonal move instead of 45 degrees and then another one taking off.
And
so
that's important because now it's much more predictable.
Yes, yes. As soon as the tool starts moving, you can really predict where it's going to travel. Where, if you're looking to miss a clamp or something as you're rapiding across the top of a fixture, it's very important for that. There's also, so that setting has 3 positions. There's none, which would mean your machine would position just like all Haas machines up to this point. You can set it to linear X, Y, Z, which means only the X, Y, and Z. On a 3-axis mill, it doesn't really matter. But if you happen to have a 4th-axis rotary, the rotary wouldn't be included in that. And then the third setting for setting 335 is linear plus rotary. And that means that all axes on your machine that are commanded in a G00 position move will start at the same time and end at the same time.
So a machine like this, or even a regular vertical with
the whole reason I bring this up is that Haas machines are going to start shipping with linear rapids on. So there will be a little bit different behavior in a new machine that you get from the factory. Setting 335 will let you revert back to the old way if that's the way you want to do it. But believe me, especially on 5-axis machines, once you've used linear rapids with linear plus rotary, you'll be sold and you'll never want to go back.
You'll never go back.
Yeah.
You'll never touch that setting again.
Exactly.
Okay, so you've done a really cool demo. Sal, if you can get in on this demo, you want to talk about a little bit what it is before we watch it?
So essentially it's a block design that we came up with to show off the features of the machine. So we needed undercuts, right? So we milled out the front. We started with the block. You'll see it in the video. We've got undercuts in the front and then cut angles, a top angle and a bottom angle. Down the center, we put a channel with some sweeping curves and then tilted that wall so we get a 5-axis simultaneous swarf tool path across there. This is not the best surface finish part we had, but the one of the machine's a lot better. It looks much better than that. And then we're drilling and tapping holes on all of the angled surfaces. So you can see there's compound angles on the end, straight angle on the back, and the sides.
Yep, we got tapped holes here on the top and on these angles here as well.
Yeah.
Okay, Frank, can you get that video queued up? And John, if you want to go over there by him and kind of narrate through it.
So my workpiece there is 3-inch tall, 5-inch wide, and 15 inches long. It's 6061 aluminum, and I cut a dovetail on the bottom so that I could hold it in our new Haas HS CV 5-05 self-centering vise, along with the 4-inch riser. Right, that allowed me to get it up off of the table so that I could tilt over and cut this thing at 90 degrees. That first tool that's running there is a Haas HS6 NP 3-inch 6-flute shell mill. It's running at 6287 RPM and 315 inches a minute. Chip loads 8.5 thousandths. It's a 90-degree cutter, and the inserts each have 6 edges on it. So this is brand new on the website last couple of weeks, but it's a terrific cutter and really ripped this material. You'll see we're facing all 5 sides of this material to get our stock down to the final size and the height dimensions. You'll notice throughout the video that the coolant comes on and then shuts off again. Well, that's just me pressing the coolant button, trying to keep the coolant down for the video so that you guys can actually see what's going on. So you'll see sometimes the coolant's on, sometimes it's not. Here's a 3/4 inch 3-flute aluminum. Again, this is the Haas end mill right off of our website. This is running at 20,000 RPM. It's 5 thousandths per tooth, giving us 300 inches a minute. The widths and cuts vary throughout this, but basically it's taking 712-inch width of cut and 190 depth of cut. So you can see we're roughing undercuts and then putting the angles on top. Let's see, there's a cutout through the middle I talked about when we were looking at the part earlier with sweeping curves, so we're roughing it there. You can see now we're going to tilt over and come in and do the full 5-axis swarf tool path on that. And after this swarf is done, we're going to come back and face mill the corners. We're putting a compound angle on each of the 4 corners. Drilling, chamfering, and tapping will be coming up next. The tapping was really interesting. It was very easy to program. We used a non-vertical rigid tapping cycle, and then went and got a plug gauge out of QC and came over, and man, those holes were so tight. So perfect. The fit was really snug. That thing wouldn't really jog around in there at all. The plug gauge really came out great. This machine is terrific. I enjoyed working on it very, very much.
All right. All right. Thanks, John. Frank, are we back? All right. Thank you, John. So look at the GM2 5-axis, the VR8. Encourage you to go on HaasCNC.com and check out the pages. There's a ton of technical information on there. If you go on the product detail page, we call it, for each machine, there's a tab called Details. And you guys put a lot of information in those Details tabs.
Yeah. A lot of the information that I kind of breezed over in this about G268, custom planes, and other codes that are available on these tilting head 5-axis machines are in those detail pages on all of the models for the VR8, 9, 11, and GM2 5-axis.
Right. And while you're on the website, I'm going to mention it one more time. Don't forget the Unlock the Savings promo. Go to HaasCNC.com on the homepage, and this week only we have an additional 5%, so make sure you check that out. And that's going to conclude the morning session. I want to thank you guys for watching as always.
Thank you. Thank you very much.
We'll be back live at 10 a.m. and we're going to be just to my right here. We're going to do the VC400 with Milton and Andrew. And then when that's done, Andrew's going to walk about another 10 feet and he's going to do the EC500 50 table with Marcus. You really want to check that out. Big, heavy cutting machine. We've got a pretty impressive demo. Now, between now and 10 a.m. Pacific, we've got a bunch of pre-recorded content, as Andrew said. Make sure you check that out, and we will be back at 10 a.m. Thanks for watching.
Thank you.
Introducing MyHaas, a free feature available to anyone on HaasCNC.com. If you are a current Haas owner or machine operator, if you're involved in buying or maintaining Haas machines, and even if you are not currently a Haas user, but want to build and price a machine online, MyHaas has something for you. Monitor machines in your shop with My Machines. Here, you can see all the machines you're responsible for and group them in whatever way you'd like. Operators and supervisors can even create their own groups in a way that makes sense to them. Click on any machine and quickly see your machine's serial number and warranty start and end dates. Scroll down for a complete list of that machine's options, including recent service updates, or with a single click, jump to the product detail page to check specs, layout drawings, even to download 3D models. In the event you need to order a part to service your machine, or if you're looking for a performance-enhancing option, Haas Parts is just a click away. As if that's not enough, our helpful and thorough service website is also right at your fingertips. Here, you'll find comprehensive troubleshooting guides, how-to procedures, videos, and operators manuals for just about every vintage of Haas machine that we've ever built. And the best part is, all of this helpful information and all of these support services are pre-filtered based on the machine you've already selected. The My Haas Connect tab lets you see the status of every Haas NGC machine in your shop at a glance. Scroll through for the current status and last recorded event for each of your machines. In My Quotes, build and price as many machines as you'd like and save them for viewing or editing later. This makes it easy to compare machines and find the one that's right for you. From there, you can send the build and price to a coworker or friend or anyone who might be involved in the buying decision. And when you're ready, send it to your local Haas factory outlet when it's time to move forward. My Haas allows you to be more efficient and manage your shop and your machines like never before. And best of all, it's completely free. Create a free My Haas account today.
You know, it doesn't take much effort to install the Haas robot package on your mill. You literally roll the robot right out of the shipping crate. All you need is a tape measure and a simple bubble level to align it. The cables that link it to your control are all clearly marked and ready to plug in. Your service tech will drill a couple of holes and move some shelving to get the enclosure ready to accommodate this huge leap forward in automation. And that's the mechanical part. But what about integration? Well, the Haas control is already set up for the robot, so your service tech will have the integration done in well under an hour. And that's it. It only takes about a day to get your versatile, efficient robot package installed and ready to start making you money. If you're ready to take a step into automating your production, the affordable, versatile, and easy to install Haas robot package could easily be what you're looking for.
Welcome to Factory Spotlight. We're in front of Haas Automation in Oxnard, California today, and today we're going to give you a tour of the demo room. I'm Brian, he's Andrew, and Andrew, let's head through these doors and take a look.
All right, let's head through the front doors here, and we're gonna head off to the right towards the demo room. As you can see, we got several trophy cases from all the different various race car wins we've got. Driver's suits, helmets, memorabilia, of course. But here we go into the demo room. You can see the sign there, and you're gonna start us off, right, Brian?
I'm gonna get rolling. The first thing as you walk through the doors, you can't help but notice a car. So why do we have a race car in the demo room? Well, this is the car driven by Kurt Busch in March of 2014, and it was his first win as a member of Stewart Haas Racing. And as you can probably see, this car is in the exact same condition as it was when it came out of Victory Lane. It's covered in, I don't know, beer, champagne, Gatorade, you name it. Pretty cool accomplishment, and we haven't even touched it. We literally rolled it right in here. Right behind me, this is kind of the star of the show. This is the very first machine ever built by Haas Automation. If you've ever seen our mill names, VF1, VF2, VF3, etc., this is the VF1. And that name comes from, remember, we had no marketing department back in the day. VF1 stands for very first one. Back in 1988, the goal was to build and sell a machine for under $50,000. And that's exactly what Gene and his team accomplished. This went to IMTS in 1988. We had a couple of folding tables and one machine. We sold a whole bunch of machines. It still runs. I'm not going to turn it on today, but the thing still operates. You can also see, really before even the first machine, the way Haas Automation started is Gene started making rotary indexers. Put a stepper motor on an indexer, and instead of indexing that thing manually, now you had a powered indexer. Also in here, we sold our 200,000th machine a few years ago, and the customer was so appreciative. They have many Haas machines. It was a UMC 750 that they made this and actually presented it to Gene at IMTS. So pretty cool piece of memorabilia here.
All right, so we're gonna go from one of our oldest machines to perhaps one of our newest offerings. As you can see, this is our small footprint ST10 turning center that's married up to what we call the Haas robot package. And this is the smallest robot that we're offering right now. This got a 7 kilogram payload, 6-axis robot, and what's really kind of amazing about this assembly is that for the same price that we were asking for that VF1 initially at $50K, you get this entire robot package for $50,000. That gives you this safety enclosure on the outside. The robot, of course, itself, it comes standard with a single gripper. There's also an option for a dual gripper. The base, all the mounting hardware, the robot controller. But what's really kind of the most important and the most useful for an operator or an owner is that this thing is plug and play, ready to go. There's no robot integrator needed or anything like that. And the beauty of it is when it comes time to programming the robot, all of that is handled through the Haas control. We use a series of menus in our familiar VPS system, and through those menus, you control the programming of the robot, and you also jog the robot with our remote jog handle, which has been updated to control the robot. So just a fantastic package and a really easy entry into the world of automation. Moving on, let's go over here to this VF2 SSYT. The VF2, of course, is one of our best sellers, our small footprint VMC. But this is the Super Speed Y variation. Super Speed, of course, gives you faster rapids and cutting speeds, 1,400 inch per minute rapids, 12K spindle, 30 pocket Super Speed tool changer, and then in this case, the Y option gives you additional Y-axis travel for a deeper work envelope this way. All right, that pretty much wraps it up here for the VF2SSYT. Let's throw it over to Brian.
All right, as Andrew said, right next to the VF2SSYT, we've got the DT1. Now, DT stands for drill tap. This is a super fast little machine, 2,400 inch per minute rapids, tool change in under a second, but it's got great milling capability too. It's got a 15 horsepower spindle. Speaking of spindles, 10,000 RPM is standard. We've got 12, 15, and 20K optional. So if you're drilling a lot of small holes and you want that high RPM, you can get it with this machine. Now on the table here, we've got a real fast 2-axis rotary. This is what we call our TRT 100. So DT1 with the TRT 100, you have full simultaneous 5-axis or just 3+2 capability. Now we're gonna move from the DT1 just to the right here to the UMC 500 SS. So this happens to be an SS, a super speed, but we have the non-SS as well. This is the smallest of the UMC family. So this is the UMC 500. We also have the UMC 750, and then the big boy is the UMC 1000. Now the nice thing, the great thing about the UMC 500 is its size. It's a compact footprint, similar in size to a VF2. So if you have a small shop, but you're wanting 5-axis capability, this machine will fit in your shop. And the cool thing about it, as you can see here with this low door, is you have great access. So if you're loading and unloading parts, it's easy in this machine. Now, as we come around to the side, we've got a big side window here. And the reason this is designed in is we'll have the ability to add either an APL, an auto parts loader, or even a pallet pool to this machine. So lots of capabilities with all our UMCs. Now we're gonna move just to my left, and Andrew's on the VF3YT50.
As Brian was saying, VF3YT. Now what's special about this machine, it's of course our medium footprint VMC. But in here you see, we're kind of the star of the show here, 50 taper spindle. If you're doing lots of hogging, but you want to do that in a space that doesn't take as much as one of our really big ones like a VF8 or a VF10 or something. If you don't need quite that much table space and travel, then this fits the bill. 50 taper spindle, 30 pocket, 50 taper tool changer. Really, if you're getting to do some hogging, but you need to do it in a smaller space, this is the machine for you. Moving on, let's go to this one here. So this is our new long bed ST30. ST30 LY, Y-axis lathe in this case. And of course, you're gonna buy this machine because you need to turn long parts, or maybe you need to turn intermediate length parts, and maybe you want to do that with our steady rest. So you're kind of in one of two situations here. Either you're going to run a really long part in which you're going to support it by the tailstock, or maybe you've got an intermediate length part that you're going to support with your steady rest for doing deep hole drilling and end work on that shaft. Very easy to move the steady rest back and forth. But another cool thing is, let's say I've got this little part in here. Now, if I've got a part like this experience is pretty much just like running a regular ST30. If I'm running a short part, this is going to be the same as when I'm running an ST30, so that's really nice. Another cool feature about this machine is you can see this hole here, if you will. This is what we call the extended Z pocket, and this gives you a lot of clearance for boring bars and other really long tools, so you can still get all the way up here to turn on the face of your part, and you're not gonna hit those tools against the bulkhead here. So ST30 long bed, great machine. Let's move on over here to this to the APL. Now this is another example of how to put automation to work in your shop for a really reasonable price. Here we're marrying our automatic parts loader up to the ST15Y. So you've got Y-axis capability on this small footprint lathe, and then you're gonna auto feed those parts, auto load those parts here from this table using this arm, and kind of like the robot allows you to. In fact, our programming process is very similar to how it works on the robot. It really started with the APLs. All of that is controlled from within the Haas control here. So you use a series of VPS templates. It just walks you through. I've got these GIFs on screen here to show you what you need to do. And then to jog the machine, you're going to use the remote jog handle, in this case our new touchscreen one. So it's very easy to move the APL arm into the position that you want to program, turn on APL mode, and the thing works automatically. If you don't need it to work in that mode, you just turn that off and use it like a regular lathe. Pretty straightforward. Let's throw it back to Brian.
All right, now we're at the CM1. CM stands for compact mill, and you can see why. Small little machine. This is an ISO 20 spindle, 30,000 RPM standard with a 50,000 RPM optional. So obviously when you have small tools, you need that higher RPM. This machine has it. Automatic tool changer, and this is primarily medical, dental, aerospace, somebody doing some prototyping. Great little machine. Obviously it'll fit in a small space. And the cool thing about this is this can run on single phase power. So if you're thinking about putting this in a medical or a dental office, you don't need 3-phase power. Okay, right next to the CM1, we've got the mill version of the APL. So the same great programming method that Andrew talked about. Everything's programmed through the Haas control using VPS templates, the remote jog handle. Little different configuration. We've got the 2 grippers, one for loading and one for unloading. Same great programming features. And we've also got an air vise provision in here. So obviously when you're running unattended, you're not going to be opening and closing the doors. Auto door, air vise, complete unattended operation. We're going to move to my left, toss it back to Andrew, and he's going to talk about the TM1.
Alrighty, TM1P. Now, the TM1 and the TL1 are machines that are equally at home in a production environment, or maybe more in a school environment, or kind of a inside your garage kind of environment. Really what these machines are about is introducing CNC machines to someone who's coming from a manual machine background. If we see here, this has got the table and the layout very similar to an e-mill, Bridgeport style machine. But this is a true full CNC machine. In this case, this is the TM1P is kind of the slightly improved version of the TM1. TM1 comes at about $31,000. This is $35,000, and for that extra $4,000, you get a lot of bang for the buck. You've got a 10 pocket tool changer, a faster 6,000 RPM spindle. It's really, this kind of takes it from a more manually oriented kind of experience to really a full production CNC machine. This is just a step away from our VF2 style of VMCs. All right, let's move over to the TL1. This is kind of the same concept here. If you're coming from a manually controlled lathe, then this layout's gonna be very familiar. Chuck's right here, steady rest, cross slide. The basic version of this machine comes with a single tool post here. But in this case, we've got several options of this machine. We've got the e-hand wheels, is what we call them. This is kind of a manual method for jogging these axes around. You can see here, I can jog these very much how you would in a manual machine, but you can also run this in full CNC mode. And that's the beauty of it. If you want to approach it from a manual perspective, that's easy. And also, when you're ready to move on to controlling it via CNC, it works great that way as well. And you've got the same style of VPS templates here. I can do a whole bunch of different kinds of features here. All I have to do is enter the important aspects of my part geometry into one of these templates here, and the VPS templates will output a complete program, and I can run that. No need to know G-code to start with. So, TM1, TL1, both aimed at getting a manual machine operator used to using a CNC. Let's throw it back to Brian here on the CL1.
Okay, I'm at the CL1. I talked about the CM1 earlier, the compact mill. CL1 stands for compact lathe. And again, you can see why this machine also can run on single phase power, so that's important if you're running in a small shop or a garage, or if you're a beginner. But this machine has a lot of fully production features. So let's come under the hood here. First of all, this machine comes standard with an 8-station turret. And in this case, this machine has a couple of really cool features. We've got a little parts catcher here, and we've even got live tooling. So you can add a bar feeder. So we've got 2 different lengths of bar feeders. So if you add a bar feeder, you put the live tooling and a parts catcher on here, you can run this thing fully in production mode. Of course, you can also run it as a chucker lathe and make small parts. Okay, let's go right next door here. And this is what we call the desktop mill. Let me open this guy up here. So this is a fully functional CNC mill. And the great thing about it is, even though it's limited on travels, it's not really a metal cutting machine. It's designed for wood, machinable wax, things of that nature, plastic maybe. It is a full CNC machine in the sense that This is not a simulator like you're used to a Haas simulator. This is actually a full-blown control. So if you learn how to program this desktop mill, this same programming applies to a VF2, a DT1, a UMC, any of the machines that we've shown you here. So really geared for beginners and in particular schools.
Thanks guys for joining us on this tour of the demo room. We've looked at small machines, large machines,
all the way up to 5-axis machines, a 50 taper,
robot package,
everything in between. So we're going to do more of these factory spotlights. We appreciate you watching, and join us next time for some more of the Haas factory.
Thanks.
Hi guys, I'm Marcus Imes. Thanks for tuning in again. I want to show you around one of our most popular new products, the desktop mill. It's our most compact and economical way to learn the Haas control and 3-axis CNC programming. We designed the desktop mill to be the next step up from the Haas control simulator as a training tool. Although the control looks like a simulator, it's actually the exact same full-featured control you'd find on any of our other machines, like the VF2 over here. I want to show you how easy it is to set up the desktop mill and use VPS conversational programming to generate some code. So you can see here I have a couple blocks of plastic on the table to work with. We mostly recommend cutting plastic or machinable wax on this machine since the material is cheap and reduces damage if a crash occurs. Or, for the ultimate in simplicity, we offer the spring-loaded pen attachment which mounts directly in the spindle. Then you can put a clipboard and a piece of paper on the table and use the desktop mill to draw shapes with CNC code. But today, we're going to make some chips. So, I have my 1/8 inch 3-flute end mill, and I'll tighten this in the spindle. I should mention the spindle has a permanent female ER11 collet interface for the spindle nose, so you'll need a set of ER11 collets for each machine. Now, I'll tighten my tool in the spindle. It's a small tool, so don't over-tighten it. Next, we need to give the machine some Z geometry. So, we'll set our Z-axis offset to the top of the stock to establish my Z height. I have a piece of paper here we'll use as a shim to pinch between the tool and the workpiece. Now that I've made contact between the tool and my workpiece, I'll use this as my work offset for my tool. Now, I'm going to set my work offset. I'm going to hand jog the spindle to where I want to set X0, Y0, and then set my G54 work offset. So let's do that. Move up Z a little bit. And I'm just going to eyeball this, but if you wanted to be more accurate, you could use an edge finder as well. So I'm going to set my X0, Y0 where I'm at right now. I'll go over to my offset page. From the offset, I'll hit F4. And in this case, looks like we already have some numbers in G54, G55, so I'm going to use work offset G56. I'll push part 0 set for X and again for Y. And I'm going to leave Z blank, although on most of our machines you would set a Z work offset. Here, all of my Z geometry comes from my tool, since there's no tool changer on this machine. Now that I have my X, Y, and Z established, let's go to VPS and make a short program. You can find VPS under the Edit button, then tab up to the top and over to VPS, and then go down to the VPS, and we'll go over. As you can see here, you have a few different shapes we can easily make, like bosses, pockets, drill patterns, but today I think we'll do a little engraving. So let's see what it takes to operate one of the VPS templates. These are all composed in a very similar manner, and basically you're just answering questions from top to bottom. We have useful pictures that help determine what inputs we're looking for, and we have some help text down here. So the first thing it's asking for is our work offset. By default, it chooses G54, but if you remember, I set G56. So I'm going to enter 56 and enter button, and now we're using offset G56. Next, it's asking for a tool number. I can tell we are currently using tool 2 from the offset table, or from the memory screen, it also tells me tool 2 is currently active. I'm going to leave that alone since we don't have a tool changer, so 2 is a good number. Now it's asking for my spindle speed. How fast do we want the cutter to turn? I have a valid range of 50 to 24,000, so quite a bit of range in there. I'm going to choose 5,000 RPM just from my experience, and I know that that won't be too fast for this machine. Since we don't have coolant, I don't want to melt the plastic, so I'm going to select 5,000 and press enter. Next, I need to give it a feed rate. How fast do we want to move? Well, how do we calculate that? Since I selected 5,000 RPM, and I know my end mill has 3 flutes, and I know a good chip load for this plastic material is 2 thousandths per flute, I take 15,000 times 0.002, which would give me 30 inch per minute. So I'm going to enter 30 with a decimal because this one requires a decimal. Next, M8 is asking coolant or no coolant. This is a code all new machinists will learn very early on. And this is one way that VPS reinforces codes where applicable. So if you're choosing a canned cycle or like coolant on, coolant off, we're going to reinforce that with the actual M or G code in the template. In this case, we don't have coolant, so I'm going to enter 0. Now it's saying, where do I want to start? Since I positioned my G56X0 at the position that I want to start engraving, I'm going to leave this one as 0. But I am going to move Y up about 100 thousandths to get us off the center line of the part. So I'm going to enter 0.1. Now here is my rapid plane. The rapid plane is where the tool changes from G0 rapid approach to a G1 feed move. The default we have in there is 100 thousandths of an inch. I'm going to leave that alone because that's a pretty industry standard number. Now it's asking for my Z depth. How deep do I want to cut? I know that this plastic top, the red plastic on the top of this part, is 50 thousandths deep. So I'm going to say give it a value of maybe 70 thousandths, so we cut down below into the white. Now we can do either text or serial number or a specific number if we wanted to do that. In this case, I'm going to leave it 0 to select text. And we could, it's asking how high do I want it. A ½ inch looks good to me. And do I want it on an angle? In this case, no, I'm going to go straight across, but you could also do it at any angle around the circle. And now at the bottom, what do we want to engrave? How about Haas CNC? And that's the last line of this template. So from here, we can do a couple things with it. If you notice up here, we have generate code with F4. So we can copy it to the clipboard if we wanted to paste this into a program. I can output it to MDI, or I can create a new program with it if I don't already have one established. In this case, I'm actually going to use the fourth option, which is just pushing cycle start, and that will run the template directly from this page. But before I do that, I'm going to move my machine away from the stock a little bit. In case I entered any bad numbers, I want some time to push stop. So let's do that. So first thing I'm going to do is move Z away from the table a little bit, just in case I got anything wrong. This will give me some time to realize that and stop it before I crash anything. So I'll go back to my VPS template. I'm going to change my rapid down to 5%, and I'll hit cycle start. Once I'm confident it's moving in the right direction, I can change that rapid override to a higher value. Now since the desktop mill doesn't have a tool changer, the first thing it's going to do is move to the back corner to a safe position and ask me if the right tool is loaded in the spindle. This way you can make a program with multiple tools even without a tool changer. But since we already have the tool in the spindle, per the message on the screen, I'm going to push the letter K to continue. And now I'm going to change the rapid override down a little slower. Now that we're moving in the right direction, it looks like. Speed it up a little bit. And just to make sure I got all my heights correct, I'm going to stop it just before it gets to the material and look at my distance to go screen. So I'm going to press position and then tab over to distance to go. I see I have 49 thousandths, which looks about right. If that number was drastically different, that's your first warning that something is wrong and you should stop and double check everything you've done. Now that I've verified my distance to go is good, I'll press cycle start and continue. So, I think you can see why there's a lot of excitement around the desktop mill. It takes a full-size machine's capabilities and shrinks it down to about the size of a mini fridge, but still allows hands-on setup, programming, and troubleshooting experience which directly translate to our full-size machines. Check out HaasCNC.com to get a custom quote on your own desktop mill with our build and price tool today. Thanks for joining us.
Good morning, guys. We're here in Oxnard, California at the Haas factory. And today, we're going to give you a tour of pretty much the whole facility. So let's go in through the front entrance here and get started. All right, so this is the main entrance, of course, the lobby here. Now we've got racing memorabilia on each side from all of Haas's race teams, but we're not going to look at that right now. Demo room's over there. We've got another video that covers that. Right now, we're headed towards the machine shop. We're here in building 1, of course. We've got 4 buildings on campus here, totaling over 1 million square feet under roof. And we're going to start in building 1 on the machine shop side, as I just said. Right here, actually we're on the other side of this wall, is rotary assembly. We'll be coming back to that quite a bit later here in the video. Right now, we're headed towards the machine shop side of building 1, and this is where we house a lot of our FMS systems. So, building 1, machine shop side. As you can see here, we've got some rotary table bodies that are surrounded by them actually. HRT 1000, our largest rotary table. TRT, rotary bodies, and trunnion castings. HRT 310s, 210s, 160s, runs the whole gamut. But on this left side here, this is kind of what we're going to focus on for right now. All throughout the factory here, we have a variety of different FMS cells, or flexible manufacturing systems is the long name for them. Right here we've got these Machinos, several Machino cells tended by these pallet walls here. And really this just signifies Haas's investment in the right tool for the job. We've been using large FMS cells since before I started in 1997. So the concept and reasons are well founded. But we continue to make new investments in these systems because it's the right approach in some cases. People ask, why aren't you using Haas machines throughout your entire factory? And the simple answer is, these large HMCs and pallet stackers are not the market segment that Haas is building machines for. But it is the right tool for the job in this case. A high mix of parts at a medium volume makes these pallet stackers ideal. The concept is simple really. Machine the right part at the right time here in the machine shop so that part is ready to put together on the assembly side of the factory when it's needed. And keep these spindles turning as much as possible. All right, so we're leaving this, the Makino FMS cells. We've also got some Japanese ones down that way. We'll probably see those on the B-roll. Anyway, you can see we got Lathe turrets here. Rounding the corner, we're going to head down this aisle here where we've got a whole line of EC400s. Now these are our earlier version, not the present one. Most of these machines were installed between 2012 and 2014, so 6 to 8+ years old. Now this is kind of an example, well this is completely an example of how Haas does the same style of machine as those FMS systems we just looked at. But in this case, it's geared towards a medium-sized shop at a much more affordable price level. But the idea here is that these horizontals are aimed at getting a high mixture of parts, or maybe you're focused on one specific part. All of these cells are mostly concentrate on 1 or 2 parts or a few parts where we're doing very high volumes. But you can see, when you attach a pallet pool like this to one of these HMCs, you've got a lot of fixture positions. And the idea is, with the pallet pool loading and the pallet changer loading those pallets in and out of the machine continuously, your spindle on time is maximized. You can see right here, we're making motor housings for our machines. Just one example of all the different parts we make on this line here. All right, so we're right next door to where we just looked at those EC400s. Now you can see, we've got this line of BMC 1000s. These replaced older models just recently, but the idea is the same here, just from much larger parts. Each one of these machines has 10 pallets, and you can see we've got a variety of different castings. We've got saddles, bases, just a huge part mix, but on these huge 1,000mm pallets, the focus is large parts, of course. All right, moving on from those FMS cells, this is one of our 2 cylindrical grind areas. We've got kind of a variety of robot-loaded and manually loaded cylindrical grinders, and you can see right here we've got a robot tending this Studer grinder. They do spindle shafts, of course, all the different kinds of shafts, transmission shafts. As you can see here, we've got large variety of different output shafts, transmission shafts. Anyway, let's head around here. More cylindrical grinders, and then right past these machines here are our gear hoppers, and we'll take a look at that in a minute. But let's head this way. Over here, we have this giant, this is our newest gear hopper here, this giant modal gear hopper. And we bought this primarily to focus on the largest rotary gear sets that we make. Now you peek in here right now, this is an HRT 310 gear, if you want to take a look in there. But really, this is focused on HRT 600, 800, and 1000 rotary table gears. So really large gear sets. Anyway, huge gear hopper. Now over here on this side, we've got really the bread and the butter of the gear hoppers here. These focus on HRT 160, 210, 310, and up gear sets. And the thing here is, these are, we've got millions of dollars of machinery here, but it's not just the machines. You can't put these into your shop and expect to be making high precision gears that fit perfectly and yield really good rotary accuracy, a week later. You also have to have the crew of professionals that have all the wisdom and the knowledge to make those machines run correctly. And that's what we've got here. All right, this is our inspection room here, considerably quieter than the rest of the factory. This is just another example of Haas's commitment to quality. We've got a huge variety of measuring tools in here, but probably you'd say the star of the show are all the different CMMs we've got here. This largest one is 3 by 1.5 by 1.5 meters. Use this for measuring our largest castings. We have a variety of other measuring tools. We do something like 15,000 tools that we calibrate every year. Gear checkers. Anyway, all kinds of cool stuff in here. Well, let's head this way for now. All right, so here we're standing in front of these giant MPCs, focused, of course, on huge parts. We've got UMC bases behind us, big SD50 base here. Anyway, you can see that these are pallet-fed machines as well. You can load your part here. You can load your part here while you have another batch of parts running on the machine. So it's kind of the same idea as the other FMS systems, just for much more massive parts. All right, we're just leaving the machine shop side of building 1. So we've just done one half of building 1. We got a long way to go. But out here, it's kind of an example of, just the basic infrastructure of the factory. You can see here we've got compressors, and we're looking at about 650 horsepower, something like 2,700 CFM of airflow. That's quite a bit more than your standard shop. Past that, we've got our coolant recycling area, and on average, we're recycling about 3,000 gallons of coolant every month. We evaporate the water and then recycle all the used oil, of course. Also here you can see our propane area. This is where we have all the propane tanks to fill up the 200 or more forklifts we have driving all over this place. And then you can see these castings here. Anything that's marked as red like these are our first article castings coming in from inspection from our casting vendors all over the country and all over the world. So let's keep moving. We're gonna go head on over to building 2 to look at some more of our machine shop. All right, so we just walked into building 2, and this is of course the machine shop side of building 2. In fact, all of building 2 is pretty much machine shop now. Behind us are, of course, more FMS cells, and really it's the same story. We use these to build a high mix of different parts. On this side, these machines are mostly concentrating on aluminum these days. But the idea here is that overall in this machine shop, we have about 60 machines dedicated in FMS cells and over 1,000 pallets. So I don't know if it's the biggest in the world or in this country, but it's huge to say the least. All right, so we've left the area with the FMS systems. Now we're back over in another area devoted to really large machines. This right here, this VB3 from 2005, I think it is, you can see is still being used. Right now we've got an EC 1600 table sitting on here. They've got a rotary control box hooked up to it. Not sure what they're doing, but they do kind of one-off stuff on that machine from time to time. And then right here we have more of the older MPC double column machines, focused of course on the largest castings. These have been here for a long time, but still chugging away. And then on this side, we've got these Akuma MCRs. This is just essentially a newer, a little bit more sophisticated, quicker version of the same thing. All of these machines, of course, are pallet fed. So you've got a part waiting to go. You've got your part being machined, and then as soon as it's done, it moves out of the way and you load another one, so you're maximizing spindle on time. All right, this is gonna be the last FMS that we'll look at today. This here is one of the largest FMS systems in the entire world based on the number of load stations and the linear number of pallets involved. Here we've got a really large mix of parts. You can see all the castings up there on the pallet wall. Lathe spindle heads, lathe gearbox housings, tailstock housings, just a really wide variety of parts, all made basically just in time for the production line. So now we're entering an area that's filled completely with Haas machines. As you can see on this side, we've got one of our robot cells. This cell is dedicated to building columns, just VF1, VF2 columns, very high volume. In here we've got 4 of these cells with E1600s tended by robots. We're building columns over here, tables and saddles over here, saddles over here, saddles there as well. So these cells are all dedicated to making 1 or 2 parts at very high volumes. These are machines responsible for keeping our small and medium VF casting lines running continuously at really high volumes. So now let's head on to this side. So all of these cells use 260 EC1600s manned by a robot in the middle. On this side, we have a different configuration. This is typical of our other kind of robot cell. Here we're usually looking at 2 lathes and a mill tended by a robot in the middle. These are mostly focused, of course, on making round parts, spindle shafts, a variety of round other flat parts. So this cell here is an example of one that's dedicated to just 1 part. These are 40 taper spindle housings, of course. We go through a whole bunch of these every day, probably upwards of 50 of these a day right now. So this cell is dedicated just to making those. Now let's head back this way. We're going to take a look at what we call our batch production area. And that's just a big group of Haas machines dedicated to making a whole variety of different parts, mostly on the mostly smaller parts, turned and milled parts. Let's head over here. So this is what we call the batch production area. This is really the area of our shop that's the closest to a regular job shop. We've got a variety of mills and lathes. This particular area is a little bit near and dear to my heart because back in another lifetime here when I was a manufacturing engineer, these 4, actually most of these machines here, but these particular super speed VF2s, a little bit older, these are all around 2008 we put these into place. And at that point I was the guy that was responsible for doing the factory floor layout, making sure these machines came into place and older ones got moved out in their place. But you can see here we've got a testament to how long these things run. These have all been here for 11, 12 years or so, running non-stop. So let's head back out of here. And just like a job shop, this area is really focused on doing shorter runs of parts, stuff that the line needs right now. Now we're going to head from here and we're going to actually finally leave the machine shop and we're going to head towards assembly. Okay, so on the left here we have electrical assembly, and we've pretty much divided this area up into two different distinct areas. This is the control cabinet assembly on this side, and then over the wall we've got electrical sub-assemblies. But here you can see control cabinets that are partially assembled. Here's one we're looking at. We got our vector drive, the amplifiers for the various axes, main con board, I/O board, all that good stuff. Here's where the incoming power comes in. So we test these here, of course, as soon as they get powered up. And then when we get to the assembly line, when we put those control cabinets on the machines, we test them again there from the point at which you're doing the squaring, as soon as you can move the axes, all the way through till final assembly when we're doing the test cut and all that sort of stuff. Okay, so we're leaving electrical assembly. Now we're getting into the actual assembly area where we put the machines together. On this side, we've got large VMCs, and on this side, we've got UMC assembly. We call these the cast assembly areas. This is where we put the foundation of the machine together. If you look at this VMC, for example, right here, you can see we've got the base, saddle, table, column, spindle head, and we put these machines together all in quite a similar way, really. It's what we call the stacked axis method. It's pretty simple, really. We start with the base on the ground, lay down the linear guides, then the saddle, then the table. Typically, we build the column offline separately. We'll put down the linear guides and ball screws there, and then we'll attach the spindle head to that, and then we'll lift that column assembly and put it onto the base. And there you've got your entire basic machine assembly ready to go. Then from that point, it leaves this casting assembly area here, and we move on to what we call the final area. So this is the UMC final area. A few years ago it was only the UMC 750. We've got one of those right here, of course. But these days, we've got the smaller brother and the larger brother to the 750. That's probably UMC 500 right here. See, just a little bit smaller, small footprint. Moving from that to the biggest one we're offering now, this is the brand new UMC 1500 Duo, in this case an SS version. Here we've got the trunnion rotary table and a VF2 table. So you've got two complete different work envelopes you can take care of. Lots of possibilities here. Let's go across the aisle. Now we've got, over on this side, we've got UMC 1000 SS. So the super speed big brother to the 750 and the 500 right here. So of course, when we come to the final line, the idea here is after the casting assembly is done, here in the final line, we take care of the geometry of the machine, aligning all the axes. Then we put on the sheet metal, install the control, and then do all of the testing that goes into making sure that the machine is ready to go. Okay, so leaving the UMC area, now we're entering where we build all of our EC machines. This is our brand new EC500 50 taper. And we're gonna be looking at this later in the show, but brand new machine, just released. This, I believe, is the first one. Right beside it here is one of our EC400s, pretty much in the same stage as those other machines we saw. Here we build these machines all in one spot. We don't have a casting area and then a final area because the production levels are lower, and since they're even larger, we typically like to just leave them in one spot and bring the sheet metal to them as we assemble them. Now let's walk through. This is where we build our GR gantry routers and our GM gantry mills. You can see this right here, GM25AX. Got this 5-axis head on here. This has got the extended Z travel. Super capable machine for doing really large 5-axis parts. So now let's go leave this GR area and we're gonna walk straight back over here. So now we're in the VMC, large VMC final area. And this machine is an example of one that's in the middle of getting the geometry checked. It's kind of the same for all these different lines. You get this machine out of the casting area and you're gonna line up all the different geometry of the different axes, make sure everything's square, perpendicular. And then from there, you're gonna start installing the sheet metal, and then it goes through the whole plethora of different tests leading up to the final test cut. Most of these, you can see we have some machines that are enclosed down there getting ready to be test cut. So these cells here are an example of how we do kind of medium volume, medium sized castings and keep the spindles turning as much as possible. Here we've married up, we've got a whole bunch, like 7 of these cells, and typically it's a VS3 married up to one of these Mideco pallet changers. So here's the pallet changer, and up here, of course, is where the machining is happening. So we've kind of run 2 different things here. Medium-sized lathe bases, small lathe bases, and then on some of the other cells we run medium and small VMC castings. So let's go walk down this aisleway here. So we've been running these VS3 cells for easily more than a decade here. But more recently, we've teamed those up with these Mideco pallet changers. And it's the same idea as we see on even the FMS systems and any of the EC400s. You're carrying multiple parts so that you can keep the spindle turning the entire time. You've got one part staged, one part being machined, so you keep that spindle turning. Let's go through here. We can see more of these pallet changers. Here we are where we're getting ready to load these small VF bases onto here so that machine will run those. Now let's leave this area here. Got one more thing I want to show you before we leave this building. Here we have 2 cells dedicated to making just the side mount tool changer cams. And we used to have EC630s that were custom modified, making these castings. So quite a sophisticated machine. And these are sophisticated, but it's kind of a more simplistic approach. If I come in here, you can see this is just a VF3 with a customized TRT210 rotary table on here. It's just essentially an offset platter mounting, and these cells are dedicated to cranking these cams out all day long, every day. Got another one right over here, and that's just because we make a lot of tool changers every day. let's head this way. We're gonna take a quick walk through the casting yard here. Okay, so we're entering the casting yard here, as we call it. This is a favorite for when we're doing real live tours, of course. Now, this is where we hold the bulk of our castings before they get machined. As you can see, we've got castings on every side. Large VMC columns over there. Small, medium bases here. Let's keep walking this way. More medium base castings here. We're looking at around 7 million pounds a month right now. 350,000 some odd pounds of cast iron machined every day here. We get our castings from pretty much all over the world. USA, Canada, China, Thailand, India, Poland, and all of those castings go through the same rigorous inspection here. They all have to meet the same specifications no matter where they're coming from. So as long as they meet the specifications, we're good to go. Here are some, some more similar castings. We have UMC castings back there, UMC 750 castings. Here we have EC400 base, runs the gamut really. And what's crazy is that all these castings here, this is about a 1 month supply. We'll turn all of these castings, or pretty much all of these castings, over every month. So it's a huge amount of cast iron we're talking about. Let's keep walking through here, and we're gonna head to building 4, our inventory building, and take a look at the huge pallet racks and the narrow aisle equipment over there. Let's head this way. So this is building 4. This building houses all of the inventory for the entire factory. So in a second, we're gonna see all the inventory racks. But right here, you can see we're actually doing assembly work here. This particular line is dedicated to small and medium enclosure assembly for the VMC line. It's our highest volume line, so we put them together here, roll the motor to building 1, just a more efficient way to put together these large enclosures. Let's keep going this way. Now we've got kind of a mix of regular width aisles here, and then as we'll see in a second, we also have narrow aisle equipment, just to get more density, of course. We want to store as many parts as possible. We store literally tons of sheet metal here. Sheet metal is really the biggest space hogs, if you will. So we store a bunch of it here. In front of us here is where all the incoming inventory is handled. We typically fill and then clear this area 3 times a day. We've got some nearly 700 vendors worldwide, so all of that inventory is coming in onto this dock and then disseminated into these pallet racks every day. So in this building, we've got 34-foot high ceilings, 10 feet higher than any of the other buildings in the complex. We have precision flat floors with guidelines in the floor for use by the narrow aisle fork trucks. When we were putting this building up, we used 1.5 million pounds of pallet racking, and that gave us 17,000 pallet spaces. We have more than 20,000 different part numbers in this area and over $50 million in inventory. Typically, we're looking at about $1.5 million a day coming in from our various suppliers all over the world. As I said before, we're somewhere around 675 suppliers worldwide. We're looking at typical inventory levels of 10,000 ball screws and 30,000 linear guides at any time. We stock components from THK, NSK, Bosch, ENA, Steinmeier, and SKF. Our total consumption of these 2 critical parts is around 33,000 ball screws and about 87,000 linear guides every year. So this is the service parts shipping area here in the factory. This is kind of on one side of building 4 here. You can see these are all orders going out to our dealers. We hold about $10 million in stock here, and that's in addition to the $75 million or so that are held in all the HFO consignment stocks around the whole world. The idea is for dealers to ship service parts from their warehouses or to have those actually in the service vans that are going to the customer shops. But whenever that isn't the case, we're shipping those parts next day from here. And typically, we're maintaining a 99% same-day shipment. And if you go to our service webpage and you page down a little bit, you'll see that we actually post what we're maintaining service percentage shipment-wise every day. And typically, we're above 99%. Pretty amazing. That means that if a customer needs a part, they're gonna get it as soon as possible. So we're headed back towards building 1. We're going to end up finishing up on the building 1 assembly side of things. Just left building 4. But I just wanted to mention here, this is what we call our freight consolidation area. Most of these machines are headed overseas, but sometimes we even gather together larger shipments that are headed to the US. But the idea here is large groups of machines all headed to the same HFO that we want to group together in one shipment. So we've got machines staged here going all over the world. Who knows? Maybe one of these machines is headed towards your region now. But for now, let's head back to building 1. We're going to take a look at assembly. All right, now we're back at the very front of building 1. Actually on the other side of the wall where we first walked in at the beginning of this tour. Now, this is the rotary assembly department. Rotary tables and indexers, of course, is where Haas got its start. Nowadays, we're surrounded by a lot more than just the basic indexers and rotary tables. We can see TRTs on this side, trunnions on this side. Here's some more of the typical stuff, HRT 310, HRT 210s and 160s. If we keep going this way, here we have a whole bunch of rotary tables getting ready for shipment. And it's easy to see why Haas Automation is the market leader in rotary tables and indexers. All right, so we're coming from rotary assembly into VMC assembly, and that's probably fitting because that's basically the progression that Haas followed from rotary tables to vertical machining centers. So this is the cast assembly area, and this is actually this assembly line, what we call a flow line. We just put it in place recently. Really, this is just a more efficient way and maybe a little more consistent way to put together VMC columns. In this case, small columns. This is our highest volume column assembly that we make here. You can see that this is kitted, ready to go, so that once it's assembled here, it's taken over to this side. This is where we do the entire stacked axis method we were talking about earlier. We place the base on the ground, add the linear guides and ball screws, install the saddle and table, and then we take that column assembly that we built over here, lift it with a crane, drop it onto the top of this guy here, and you essentially have the bare bones of the machine. Then we take this finished bare bones machine here, and we take it across the aisle, and we head into what we call final assembly. And here, we finish the geometric alignment of the machine, make sure all the axes are square and everything perpendicular, and then we start installing sheet metal. You can see these machines here. This machine, of course, is just about ready to ship. You can see most of these machines are getting ready for shipment. In fact, this one's being cleaned up, prepared for shipment. This will probably be going out later today. Now, we're going to keep going. We're going to leave VMC assembly and head towards lathe assembly. Okay, so we've left VMC assembly. Now we're entering the lathe assembly area. As you can see right here, we have some assemblies that are getting ready to be put onto this line. Wedge assembly here with the turret attached, all ready to go. Over on this side, we have spindle heads ready to go on the line. Another wedge assembly. Now, over to my right-hand side here, this is where we put together the small lathes, SD20s. And then over on my left-hand side, this is where we put together the ST30s. Now, similar to the mill line, we have a cast area and a final assembly area. This is the cast assembly area. Kind of the same idea here. You place the base on the ground, put down the linear guides and ball screws, and then you start adding all the large sub-assemblies. In this case, let's get back to this one here. Now you see here, we have a base casting where no assembly work has been done yet. Just getting ready, they'll level this out, then they're ready to put on the ball screws and linear guides. Right here we have an assembly that's progressed along a little bit farther. This is the bare bones spindle head right here. Here's our wedge assembly and the turret, tailstock. These are kind of all the main components that need to be on this lathe to turn into a functional machine. Ball screws, linear guides, everything's been installed. From this point, they're going to attach the control, and then they'll start building the sheet metal around it after they made sure everything geometrically is moving correctly. Let's go from here down to the final line. So here we are on the lathe final line. This, of course, is the small lathes, ST20s, 25s. This ST25 is, well, looks like it's almost ready for shipment. It'll be completely final packed up in a minute here. It's running the last series of tests, just kind of exercising the control and the axis motion. Once again here, I'm beginning to sound like a broken record, but here in the final area, we put on all the sheet metal after the geometry of the machine has been set, then we install whatever options are attached to that order, test those, do a final test cut, and the machine's ready to ship. It's going to go from here out to our shipping area. Let's take one more walk and finish up in the shipping area. All right, here we are at long last at the back end of building 1. This is the shipping area here at the factory. And this is of course where all of those machines and all those different assembly lines end up. And they get packed for shipment to an HFO near you or a machine shop near you. We'd like to thank you for joining us on this whirlwind tour of the factory here. And we really hope that the next time you're in town, you can join us here for a real live tour. Thanks for joining us, and we'll see you next time.
Hi, my name is Milton Ramirez. I'm going to talk about the Haas control today. The Haas control has been designed for user friendliness over the years. Since its introduction in 1988, the Haas control has been basically the same layout from day one. So I want to talk a little bit about that because the Haas control is, I believe, the easiest control to learn out there in the industry. A student can come and spend a couple of hours maybe with an instructor on the control and learn how to manipulate the machine and all the basic operations fairly quickly. So basically the Haas control is made up of sections, right? The first section I want to mention is the function keys. These are used in many different displays, many different pages, and as their names say, they have different functions assigned to each one of them. The next section is called the display section. This one allows you to navigate around the different screens or displays on the Haas control. Next, we have what we call the mode keys, right? It's basically 6 modes. Those are the common modes that every single control out in the industry has, which are used to operate the machine. We simplify, each mode by having a row of buttons that pertain to that mode. When I say modes, I mean edit mode, memory mode, MDI, manual data input mode, handle, jog, zero return, all the common functions and modes that the control has. Okay, next would be this larger section, which is what we call the alphanumeric section, right? This is what you use to type all your data when you're programming something manually, when you're entering information in our visual programming system. Okay, next you have the override section. This is where when you're running a program, it allows you to actually use these keys so that you can speed up the spindle as necessary, so you can later adjust your program. Also, you can override the feed rates. You can also press this button here, and you can use the handle to increase or decrease your feed rates or your spindle speeds. So after that, you move up a little bit, and then we're going to have the jogging keys. These are keys that you can use to jog the axis manually, so you don't have to spin them this way, or if your machine comes equipped with the remote jog handle, you don't have to use the handle. You can just simply stand here by the machine, look at what axis is moving. You can even lock it if you use this middle button before you press the axis key, and the machine will jog automatically. There's a couple of other buttons here, the blue buttons that are actually buttons that you use to turn on and off the chip conveyor, on and off for the coolant. You can move the coolant spigot up and down. So basically, those are the actual zones or areas of the Haas control. As you can see, it's very simple. It's not intimidating. It's easy to get around. It's pretty understandable. So I'm going to demonstrate a couple of buttons that we really like on the Haas control. The first one, it's called the power up button. That is a one touch, one push button that zero returns your whole machine. It doesn't matter if it's a 3-axis mill, if it's a 2-axis lathe, if it's a 3-axis lathe, if it's a 5-axis mill, it doesn't matter. The machine's going to do it automatically with one button push. I just press power up restart, and off goes the machine. It's zero returning the tool changer as well. That's why you can hear it moving in the background. But it's on a Haas control, it's only a few, maybe seconds, while all the axis zero return. When you come back to it, the machine's gonna be ready to go. I remember the days when I ran other machines, other brands, other controls, and maybe I had a problem with the tool change. I wasn't comfortable with the length of the tool over my part or whatever. I would press emergency stop and stop the machine in the middle of a tool change. That meant that I was gonna take a few minutes, maybe 10 minutes or whatever it may be, to recover from that. On a Haas machine, it's very different. Let me show you what I mean. I'm doing a tool change right now. I did a tool change with 2 tools in the arm, even a probe actually, so it's a little riskier. But I'm not worried about that because I know that I can come over here, I can clear whatever alarms. I pulled out the e-stop that I pushed in, clear because there's a problem with it right now. But all I have to do is press recover, and the machine is starting the recovery process. As you can see on the control, it returned the arm to its position, it returned the pockets to their original position, and it checked the whole system to make sure the tool changer is good and ready to go. So now there's a pop-up window that says that I can close it. So I'll close it by pressing cancel, and my tool changer is recovered. I can test that by doing a tool change. No problem. So recovering a tool change from maybe a stop in the middle of it because you lost power, because you got startled and thought the tool was gonna hit your part, whatever reason may be. But as you can see, recovering from that is one button push on a Haas control. I have an MDI, a program prepared for tapping. I'm gonna press cycle start, it's gonna call tool 1. The program is basically a tap. Well, my tool isn't a tap because I'm not really showing you the tool, but I want to show you what the control does, okay? So it grabbed tool number 1, it's gonna go to its position, it's gonna go to its Z offset, and it's gonna start tapping. There's many states where there's storms all the time in the United States, which means that it might be that in the middle of a tapping cycle on a very expensive part made out of titanium, stainless steel, whatever it may be, maybe you've spent hours on that part. So now what do you do when your tap is actually stuck inside your part because you lost power? Or maybe, you just freaked out like a lot of people do and pressed emergency stop in the middle of a tapping cycle. What do you do? So Haas has developed a feature called tap recovery as well. So I'm gonna clear my e-stop that I pushed myself. I'm gonna press recovery again. And now you can see that what we have is a bubble that offers me the chance to choose between tool change recovery, which I don't need right now, or tap recovery. So for tap recovery, I'm gonna press number 2. That brings up a beautiful image here that explains that all I have to do now to extract that tap from my part is either press forward or reverse, depending on if your tap was a left-hand tap or a right-hand tap. The cycle that I programmed was a right-hand tap. So I'm going to reverse the tap so that the machine right now is actually reversing the spindle and it's moving in the Z-axis at the exact same feed rate of my tap, which means it's actually extracting it out of there. So I can keep going until the machine is basically all the way up on Z-axis. I would actually reverse it until it clears the part, but if you want to, you can stay there for minutes, right? So at that point, it would have cleared my part. I'm free to maybe zero return the machine now because, I lost power. So, you would definitely have to do that. But if I want to exit tap recovery now, all I have to do is press F1. As I said, a function key again, right? These are going to have many functions in different screens. F1 to exit tap recovery. Another great feature of the Haas control that I'd like to mention is that it has the manual on board on the control at your fingertips at any time. Let's say, for example, you're not sure about a particular G code or M code in your program. You can move your cursor down, right? You can highlight that G code or M code that you'd like to read more about or know more about. Once it's highlighted, press the help key. And what it does is it brings up the section of the manual that completely explains that G code or M code. So you can see what each address is on that particular G code. It explains, as you know in the manual, every single entry necessary for that G code to work. After that, you can press F2 while you're in the manual, and that'll take you to the table of contents, which is really nice as well because then you have a bunch of information in a detailed format where you can actually choose what you want to know about the machine. Let's say, for example, there's some icons popping up over here that you don't really know what they mean. You can go and look up a list of the control icons that explain why each one pops up and what exactly it means. This is specifically to the next generation control. You can scroll down with this handle here, as I'm doing, and start looking at the icons with their explanation next to them. Okay, you can also cursor down with this key, or you can page down if you want to go a little bit faster until you find the icon that you'd like to read about. Okay, once you're done with that, you can press F2 again, and there's an actual programming section that you can go to. I'm selecting the programming section now. I'm pressing enter, and then it basically asks me what kind of program am I looking for? What kind of program examples? Special G codes, cutter compensation examples, can cycle examples. What do I want to look for? So let's say I open a can cycle section. Now that brings up drilling can cycles, tapping can cycles, boring, reaming can cycles, and then also a section that explains R planes, which is the retract planes, right? So let me look at the drilling can cycles, which are really common operation on milling machines. And that brings up G81, G82, G83, even G73, which is the high-speed drilling pecking cycle as well. So I can read everything the Haas manual, operator's manual, has to say about those codes. And then I can go specifically to each one of them for more examples as well. Okay, the help button here will take you to the operator's manual that has all the information you're going to need for any question you might have at any given time during the use of your Haas machine. Let me show you one more thing on the Haas control that I think can make our lives easier as we work on these machines. Okay, the next one is what we call the device manager. Okay, if you go to the current commands display on the control with this button here, that'll take you to a display that has several tabs on top. The first one of them is called devices. And then right under that, there's a sub-tab called mechanisms. What that means, it's an area that allows you to directly go to where you can control all the mechanism and devices that are installed on your machine. A lot of them are going to be optional, and some of them are going to be standard depending on what machine you have, okay? But it's really cool to know that you have this here because let's say, for example, I want to orient the spindle for whatever reason. At some point, years ago, I would go to MDI and type M19 and press cycle start and orient the spindle that way, right? That was the only way I could do it. But now, if I go directly here to the device manager, there's a section there that says main spindle orient. All I have to do is press F2. That oriented my spindle right now. So I have access to all the devices that are on this machine. For example, tool air blast, which is a blast that comes out right through the spindle of air to clear all your chips. I can turn that on from here, but I don't have a tool right now that has the hole going right through, so that's why you didn't hear it below. But I can turn it on and off directly from here. There's also the mist condenser, which is that option you see right on top of the machine, right? That mist condenser, I can turn it on or off from here as well by pressing F2. Turn it on, toggle it, and F2 will turn it off as well, okay? Whatever you have will be displayed here, and you'll have access to that. Let's say, for example, if I was on a lathe and I go to device manager, I can do a tool change from there. I can lower the tool setter from here. I can do spindle orientation from here. I can open and close the chuck from here. I can open and close the sub-spindle chuck from this device. Very, very useful. Let's say, for example, I'm on a horizontal machine with pallet indexing, like an EC400. I can actually do a pallet change from here by just pressing F2. That is, really, really easy, and it's reliable, and it's at your fingertips at any given time. If I had a pallet pull, for example, even then I can control the pallet pull as well. You don't have to look around anymore. You don't have to know commands. You don't have to know M codes. You don't have to know where the buttons are. Just go to the device manager, and you have full control of all the devices and options on your machine. So let me show you something called the user positions, okay? To get there, let's go to the settings page. Once you're on the settings page, you're gonna have some tabs, as you usually do, because there's a lot of different things you can do from every display. So let's move over to the right to the tab called user positions. At that point, on this vertical mill, there's at least 3 positions that you can program, okay? One of them is the user travel limit. That one allows you to actually jog any axis on this machine to any position starting from home that you'd like. And if for safety reasons or for your particular part program or for whatever it is, the application that you're running, you want to limit the travel on that axis, you can. You can just basically jog to a certain position like I am right now. Then you go back to travel limit. I look for x-axis. Once it's positioned where I want it, all I have to do is press F2. Now that position is recorded. Now I can jog away from that, but I cannot jog past that. And as you can see, the table stopped, but I didn't get an alarm, which is cool, right? But I just limited the travel on that particular axis, okay? So that's what we call the user travel limit. So allow me to remind you that each one of the features and user settings that we've talked about here today also has a video that explains it a little further on our Haas YouTube channel. So feel free to go and peruse around and look, and you'll find a lot of good information on there where you can expand your knowledge on the control.
Hey guys, I'm Marcus Imes, Product Specialist here at Haas Automation. Thanks for joining us for another Apps Minute. Today I want to show you around the new TRT210 and our pneumatic work holding option. As you can see, it's a 2-axis rotary that has plus minus 120 degrees tilt and 360 degrees rotation on the platter. It can be used with 3+2 machining, which allows you to complete 6-sided parts in 2 operations, increasing the throughput of your machine, or full 5-axis tool pass to make highly complex parts. I did some test cutting on the unit, and one feature that I really liked was the fact that we put an oversized brake on the tilt axis. Using an oversized brake means you can cut more aggressively without worrying about overpowering the brake or having to slow down to avoid chatter. We've given you a few different platter options for this unit to suit your specific work holding needs. You can see this one has the standard 230mm platter, which has 3 different bolt hole circles to attach your work holding. If you need maximum fixturing flexibility, consider the optional 210mm T-slot platter. It has 6 equally spaced T-slots and allows for easy fixturing of a variety of work holding like chucks, vices, or toe clamps. If you need to get maximum throughput out of your machine, the new 0-point platter system is your answer. The 0-point receiver is permanently mounted to the rotary, and the machinable aluminum top plate can be quickly swapped out. You can buy extra top plates so you can stage multiple work pieces ahead of time and then change them out with a few turns of the wrench. The system is also extremely flexible and beneficial if you run a family of parts and do many program changes frequently. With the quick change platters, you can say goodbye to indicating multiple fixtures and losing all that setup time. With the 0-point system, you just load the correct platter, load the program, hit go. Last, if you want to permanently attach a chuck to the rotary, we offer the spindle nose platter, which has an industry standard A1-6 spindle nose that is compatible with a wide variety of 3-jaw and collet chucks, available from almost any third-party vendor. Another option available for the TRT210 is the pneumatic work holding provision. This option plumbs air through the trunnion body, below the platter, and then through the center bore. Now you have 2 air ports that sit just below the platter surface and allow direct plug-and-play connection of the Haas pneumatic vise or any pneumatic work holding. This allows for quick, hands-free clamping or integration with a robot system like the Haas HRP series or any other. Just like all our other rotaries, we have MRZP probe templates preloaded in the software to find rotary and rotation center point, making that extremely easy with our WIPS wireless probe system. So that's the deal with the new TRT210. The last thing I want to show you is our new pneumatic work holding option. The vise is activated via M-code, the foot pedal, or from the Current Commands Devices tab. It comes standard with diamond cut hard jaws for maximum grip, and also machinable soft jaws are available in various materials and sizes as well. Notice the bolt hole pattern fits perfectly to the 125mm spaced T-slots, so you don't have to mess around with toe clamps or subplates, which reduces unproductive setup time. Also note, it runs off the auxiliary air option, so your machine will need auxiliary air to integrate directly with the pneumatic vise. The pneumatic work holding option is a great way to decrease load and unload time and increase the overall productivity of your machine. At the same time, this reduces operator fatigue and the risk of repetitive motion injuries from clamping and unclamping a vise repeatedly, which both operators and owners will appreciate. Another benefit of the system is it ensures you have consistent clamping force regardless of the operator, shift, or time of day, so you can kiss crushed parts or thrown parts goodbye. So that's what's new for this week. Thanks for joining us for another Apps Minute. We'll see you again soon.
Hi, my name is Mitchell and I'm a manufacturing engineer here at Haas Automation. Daily and weekly maintenance is crucial to make sure that you get your Haas lathe operating at peak performance. However, the reality is that some owners of Haas lathes take better care of the vehicles in their garage than they do the machines in their shops. Taking a few minutes out of your day to take care of your machine may cost you a few bucks in the here and now. However, you will be money ahead in the long run, especially when considering the alternative of paying thousands of dollars to replace worn down components on your lathe, in addition to the loss of revenue due to machine downtime. Plus, maintaining your machine might actually be easier than you think. When I get to work each morning, I boil some water to make a cup of tea. Rather than sit there and watch the water boil, I can actually get several maintenance tasks done. The first thing you should do is apply 3 pumps of grease to the hydraulic chuck at each zerk fitting. This ensures that the chuck can properly clamp down on your part so it doesn't slip in the jaws, and it also greatly reduces the risk of throwing your part, which could damage the machine or even injure your operator. Remember, if your chuck is dry and gritty inside, this adds friction to the moving parts. This force it takes to overcome this added friction is force that's not clamping your part. Check the hydraulic pressure on the side of the machine and make sure that they are set to the correct levels so that your chuck, tailstock, and steady rest all operate correctly. Next, unlike the mill, there is no designated spindle warm-up program located in the memory of the control. However, you can still warm up the spindle by running it at 500 RPMs for 5 minutes. This should definitely be done if your machine has not run for 4 or more days, but it is still recommended for everyday use, especially if running your spindle at high RPMs. While the spindle warm-up is running, check the air lines for water by depressing the trigger on the air gun, and make sure to keep it pointed away from you. Since the air gun is fed from the bottom of the manifold, any water in the system will escape when the trigger on the air gun is activated. However, if you consistently have water in the lines, this is a sign that a bigger issue going on with the compressed air in your shop. Next, open up the diagnostics page on the control and check your air pressure and the coolant level. Check to make sure they are both at acceptable levels for operating your machine. Finally, check the coolant concentration, especially when working in a high production or hot environment where the concentration is affected by carryout or evaporation. Using a refractometer, verify that the concentration in your tank matches the manufacturer's specifications, usually between 6 and 8%. Now the morning maintenance on my machine is done, and I can enjoy a nice cup of tea. After each shift, or at the end of every day, clear off any chips present on the way covers and evacuate them from the machine using the chip conveyor. Use a brush to remove the larger chips and follow up with the air gun to remove the rest. This prevents chips from putting unnecessary strain on the way cover seals, as well as ensure that the ferrous chips, such as steel or cast iron, do not begin to rust within the machine. Additionally, check the chip strainer filter on top of the coolant tank and remove any excessive piles of chips that may be present and restricting the flow of coolant back into the tank. These are all the tasks that we recommend doing every day. However, there are some additional tasks that should be done once a week, for example, every Friday. First, blow off any chip buildup on the top of the turret or inside any of the cavities. Next, inspect the air regulator pressure gauge located in the loop panel on your machine and verify that it matches the reading on the control and is within the acceptable operating range. With the diagnostics page open, check the coolant float gauge and verify that it is operating properly and the displayed reading matches the actual level of your tank. Check the surface of the coolant tank for tramp oil and remove any present using an absorbent pad. You can even use shop towels for this in a pinch. If you see tramp oil regularly, you might consider investing in an oil skimmer to keep your coolant performing at its best. If you have an auxiliary filter, check the cleanliness of the auxiliary filter bag and replace the bag if needed. Finally, if you have a bar feeder running in a high production environment, grease the bar feed push rod and bushing using a generic lithium-based grease such as Mobile Grease XHP 222. Now I know that was a lot of tasks, and some of this work is more applicable to some shops than others. You know what is best for your shop, and we encourage you to develop your own weekly maintenance checklist for your shop. But just in case it might help, we made a list of all the tasks that I just described and you can download it in the description below. And that does it for today's service video. Remember, a small investment now can save you expensive downtime in the future. For more service-related information, visit haascnc.com/service. And thanks for watching.
How can you unlock great savings on a new Haas mill or lathe, or rotary, or UMC, or even an EC? We've got great deals on all these machines. So many ways to save, it even confuses us sometimes. And we've talked about tax savings before, and we're gonna say it again. Don't forget, the end of the year is coming soon, and locking in a great deal on a machine plus adding the bonus of tax savings is a combo that's hard to beat. Go to HaasCNC.com and you'll see our Unlock Savings banner. Savings on just about any machine, rotary, or automation combination you can think of. But let's make an easy choice. Our compact workhorse, VF2SS, coming in at $65K list. Order this before the end of our HaasTec event, September 18th, and you'll unlock special pricing and get it for just $58.5. That's 10% off. Now, if I add an HRT single-axis rotary, the savings goes up to 15% on the whole package. And step up to that same VF2SS, plus say our new TRT 210 5-axis rotary. Now, we're at 20% off the whole bundle. By the way, this would put a full 5-axis setup in your shop for around $90,000. These are good deals, especially considering our stock levels are dropping as the pace of manufacturing increases. That's right. Manufacturing is on the upswing despite these crazy times. But you do need to act now because our lead times are going to increase. And you'll want to get in on those tax savings. Like last year, in 2020, you can expense your entire purchase, $58.5 for that VF2SS, under Section 179 for new capital equipment expenditure. If you're in the 35% federal tax bracket, for example, this will reduce your federal income tax bill by a whopping $20K. And all you'll need is 10% down. That's $58.50 to get that VF2SS on your shop floor. While Uncle Sam reduces your tax by $20K. Come tax time, your balance sheet is $14K in the black. Talk about tax relief. And if your credit's good, you can get financing with a 4-month skip. That'll put you into 2021 before any payments due. Of course, you'll need to talk to your tax professional to review specifics. But needless to say, now is an excellent time to invest in a Haas. Things are improving, which is great, but that means lead times will stretch. So act now to unlock this combination of savings with Haas's great deals and that 2020 Section 179 deduction.
Hi, my name is Mitchell, and I'm a manufacturing engineer here at Haas Automation. Daily and weekly maintenance tasks are crucial to make sure that your Haas mill is running in tip-top shape. However, the reality is that some shop owners take better care of their cars, which will only ever cost them money, than their mills, which actually make them money. Taking a few minutes out of your day to take care of your machine may cost you a few bucks in the here and now. However, you will be money ahead in the long run, especially when considering the alternative, paying thousands of dollars to replace worn down components on your mill, in addition to the loss of revenue due to machine downtime. Plus, maintaining your machine might actually be easier than you think. For example, every morning when I get to work, I make myself a cup of coffee. In the time it takes me to brew that one cup, I can actually get several maintenance tasks done. The first thing you should do is run the spindle warm-up program located on the program page. You should definitely do this if your machine has been idle for more than a couple of days, but it is still recommended for everyday use, especially if running the spindle at high RPMs. While the spindle warm-up program is running, check the air lines for water by depressing the trigger on the air gun and make sure to keep it pointed away from you. Since the air gun is fed from the bottom of the manifold, any water in the system will escape when the trigger on the air gun is activated. However, if you consistently have water in the line, this is a sign of a bigger issue going on with the compressed air system in your shop. Next, open the diagnostics page on the control and check for air pressure and coolant level. Check to make sure that they are both at an acceptable level for operating your machine. Finally, check the coolant concentration, especially when working in a high production or hot environment where the concentration is affected by carryout or evaporation. Using a refractometer, verify that the concentration in your tank matches the manufacturer's specifications, usually between 6 and 8%. Now the morning maintenance on my machine is done, and I can enjoy a nice cup of coffee as well. Throughout the day, make sure to check the tool holders, pull studs, and tool tapers for damage. This can easily be done each time you need to swap or replace tools. Make sure that none of the tool tapers have rust, galling, or chips present on the taper, as this can damage the spindle in addition to causing bad finishes and part tolerances. After each shift, or at the end of every day, clear off any chips present on the way covers and evacuate them from the machine using a chip auger or conveyor. Use a brush to remove the larger chips and follow up with the air gun to remove the rest. This prevents chips from putting unnecessary strain on the way cover seals, as well as ensures that the ferrous chips, such as steel or cast iron, do not begin to rust within the machine. Check the chip filter on top of the coolant tank and remove any excessive piles of chips that may be present and restricting the flow of coolant back into the tank. And finally, if there is a tool in the spindle, make sure to remove it before leaving the machine to sit overnight. Use a rust inhibitor like WD-40 to clean and lubricate the spindle taper. Spray on a small amount of the rust inhibitor and then wipe down the taper with a clean, dry rag. These are all the tasks that we recommend doing every day. However, there are some additional tasks that should be done once a week, for example, every Friday. The first of these is to clear off chip buildup on the side-mounted tool changer arm and check for sticky plungers or worn keys. If you have an umbrella-style tool changer, make sure to clear off the chips from the top of the protective cover and check the extractor forks and keys for excessive wear and damage. Next, inspect the air regulator pressure gauge, located in the loop panel on your machine, and verify that it matches the reading on the control and is within the acceptable operating range. With the diagnostic page open, check the coolant flow gauge and verify that it is operating properly and the displayed reading matches the actual level in your tank. Check the surface of the coolant tank for tramp oil and remove any present using an absorbent pad. You can even use shop towels for this in a pinch. If you consistently see tramp oil in your tank, you might consider investing in an oil skimmer to keep your coolant performing at its best. Next, remove the coolant filter from its housing and remove any chips caught in the mesh. If you have TSE on your mill, check the TSE filter on the bottom side of the TSE pump for excessive buildup that might affect the coolant flow. Replace the filter if it's necessary. And finally, if you have an auxiliary filter, check the cleanliness of the auxiliary filter bag and replace the bag if needed. Now, admittedly, that's a lot of tasks, and some of this work is more applicable to some shops than others. You know what is best for your own shop, and we encourage you to develop your own weekly maintenance checklist for your own shop. But just in case it might help, we made up a list of the tasks that I just described, and you can download it in the description below. And that's it. Remember, a small time investment now can save you expensive downtime in the future. For more service-related information, visit haascnc.com/service. And thanks for watching.
So we're here at the Haas sheet metal facility, and if you didn't know that Haas did sheet metal, well, this is going to be something different for you to see. So I'm here with Joe Kribda. Joe manages this place, and Joe was the manager for a section of our machine shop years ago, and as we go, we'll kind of tell that story. But for starters, how much of the sheet metal that Haas uses is produced here?
30% of the sheet metal that Haas uses is produced in-house at what we call HSM Haas Sheet Metal.
Okay, let's take a walk. So this machine's been here for a couple of years. I've seen this one before.
Yeah, this is a robotic press brake. It's been here for approximately probably 3.5 years. We do a lot of the pan parts on it, which is the bottom part of the machine. Normally it's a two-man job. Now the process is a no-man job. So load it up and walk off and let it run all night.
Okay, so same machine. It's an Armada here. What are we doing on this one?
Yeah, smaller Armada. We use that on a lot of the smaller parts. We got it running. It usually runs a lot of coolant parts, coolant tank parts, and a few other small odds and ends, and a lot of short run jobs. It's easy to set up, quick, nice machine.
And again, making a lot of parts with no people.
Yeah, combination machine, so it'll punch and laser. It's got a fiber laser. The laser on this thing is runs about 700 feet per minute, so it's pretty fast. Typically 14 gauge is what we run through it. Some 10, some 12, but mainly 14 gauge.
Cool. So again, you guys have invested a lot in automation here.
Yes, absolutely.
Okay, now behind you, what we talked about earlier are the pans. And these guys are just doing the deburring?
Yes, they're just deburring. Well, I shouldn't say just deburring, it's kind of a critical thing.
It is critical. Can you explain some of the design changes that you guys made on this?
Oh, wow.
I know there's a lot.
Yeah, it's kind of difficult without the actual old parts sitting here to show you what we really changed.
I remember what they look like, but yeah.
You know, we probably reduced it by 4 or 5 pieces other pieces that were on here. So this is our Armada laser system. This was here when we bought the place.
This one I remember.
It's an original piece of equipment. It's got 2 lasers. It has a load station and an unload station. And it took us a little while to get it figured out and learn it, but we got it down pretty good, and it's a good machine for us.
So, well, when you say we got it figured out, I kind of want to talk about how you got started. We talked before we got on camera, and this was a vendor's building.
Yes,
we had a vendor in here making sheet metal for us.
Yes, it was a vendor that was making sheet metal for Haas. They went out of business. They were going to auction the place off. We ended up buying the whole thing. Everything was disconnected. Nothing was turned on. And I got a call to say, hey, how'd you like to go learn sheet metal? Didn't know anything about sheet metal. I came from the machine shop. And I had one other guy. We showed up, and we didn't even know how to turn the thing on. So it took us a little while to learn it. But we learned how to get this going. We learned how to press brakes. And from there, it just grew. We started out at 0, and now we're doing, approximately $30 million in sheet metal value a year. Not bad.
Grown a lot. And because we used to work together when I was in engineering and you were in the machine shop. So I know throwing you into this was a challenge.
Yeah.
All right, if you want to keep going.
So over here we've got a couple other Trump robots. Our 7,000 cell, which does a lot smaller parts, is very quick. And then our 5,000 cell over here with the robot that we do larger parts on. We do a lot of doors, a lot of VF doors for the verticals. Our factory, since we've opened up or took over VF door production, we've done about 60,000 doors.
Is that right?
Yeah,
I've never heard that number.
yeah. And again, unmanned, which is a good thing. This here is called a panel bender, and this is one of the first machines we brought in. Nobody really ever knew what it was, but we kind of saw one day on the internet and thought, man, that would work good for us. And we kind of looked into it, and it did, and it works very well. This will bend flat panels, and it bends up. So it's limited on what it can do, but what it does do, it does fast, and it does good. That's a coolant tank there, would be a 2-man job, and it'll take probably 3 minutes, and it'll finish it in under a minute. And then we just have a guy to load and unload. So we do all our coolant tanks here, we do all our electrical cabinet doors get formed on this thing, among other parts. So a lot of parts going through this.
How many, and do you produce all the coolant tanks that we use at Haas?
20 gallon, 55 gallon, 95 gallon is still done outside.
Okay.
And coolant tank wise, we've probably done 38,000 coolant tanks since we started that. Wow. A lot of coolant tanks. On this side, we have our manual press brakes. We still do a lot of manual work. There's some stuff that's just not conducive to a robot. It's just not going to fit in. The way the angles are, the way it's made. So we still have some stuff that's done manually. Another big time saver, something else that helped out a lot is, here's a VF door over here. We used to have to manually put PEM studs in every one of these holes so we can hold the window down. Well, one of our employees, we went to FabTech, and he saw this machine there, and it's a stud welder. So what used to take us minimum 5 minutes a door to put the studs in, now takes about a minute to weld them on. So he'll put it on the table, it's got an auto feeder, it'll pop all those on, pull it off.
So the PEM studs used to be a manual process.
Used to be a manual process.
You have to pick that thing up.
On a hardware machine, you'd have to pick it up, put the stud in, press it, pick it out, put the stud in, press it.
So now this whole area, last time I was here, this wasn't here.
This wasn't here
at all.
We added this on, about 25,000 extra square feet. We wanted to make room in the other side for more automation. Plenty of storage space. Sheet metal takes a lot of room. A lot of room. I mean, if you got these things moving around, you know, look how much space you got to have. So we've moved deburr, manual welding, and then pan welding to the end, and then our 4 robotic cells over here.
Okay, so this is where they weld the coolant.
Coolant tanks are there. This is
coolant
pan,
tanks and these are
only.
pan. And this is all done manually.
All done manually, 1 pan at a time.
Okay.
That's our next big project is welding pans robotically.
Which it sounds easy, but.
It sounds easy, but this will be one of the more difficult robotic welding projects that we have.
Okay, so now we're heading into the powder coat area.
Yep, this is where we powder coat everything. So the powder coat line, this was here when we originally bought the place. We used to paint a myriad of colors. We reduced it down to 2. We paint dark and light gray, and that's it. No more red, green, and blue, and all yellow. The powder coat line itself is about 950 feet long. So it's got the 5-stage washer, uses iron phosphate to pre-treat the material, which allows the paint to stick to it. It goes through a dry-off oven, then it goes through one of 2 paint booths, depending on the color. One of the paint booths has a reclaim system, so we can reclaim the powder and not throw it away. We're setting up the other booth with reclaim now. It'll go into a cure oven where it cures. It takes about 25 minutes, comes out, and it's complete.
And you said you only do a couple of colors. Explain what it's like when you change colors.
Yeah, changing colors, you have to clean out the entire booth, and it takes probably about 40 minutes to do that. So we tried to reduce that down so we have 2 booths, 2 colors.
And how long does it take a piece to get through?
2.5 hours from start to finish.
Okay.
So not the quickest process, but you know, that's what it takes.
But except for the loading and unloading, it's automated.
Yeah, 3 guys in the spray booth.
2 guys painting. So I know we went to the powder coat, but we were watching, Frank and I were watching this earlier. You're making the regen for
this is another Trump robot. This one's kind of in an oddball spot because the building wasn't completed over there yet, and this is where we can fit it in.
You had an opening, so that's where it is.
It's just a smaller robot than the other one. It's just got a shorter, actually a shorter press brake, shorter rail system along the bottom.
So, from powder coating, what kind
Powder
of
coating, depending, it might have to go to assembly where we assemble it. That's where we assemble all the doors and the coolant tanks. And if it's not an assembled part like this back panel for a VF, it'll get wrapped up and he'll put it on the big wrapper out there and then go on the truck and head over to Sturgis.
So that was going to be you preempted my question. So you guys complete the doors,
Yes.
so that when they go to Haas on the assembly line,
Yep.
they just hang them on the machine.
Hang them on the machine.
So this is the assembly area you talked about. So they put the rollers on the doors.
Yep, like the lathe door, they'll put the liners in, they'll put the rollers on, any of that needs to get done. And they'll build all that right here. Coolant tanks are over here where they put the wheels.
And we're back where we started. That's Haas Sheet Metal. Pretty interesting place. A lot different than what we're used to at the factory, but as you can see, this is an essential part of Haas Automation. And Joe, I want to thank you for taking us on the tour and showing us everything.
Thank you, anytime.
Thanks for watching, and we'll see you again soon.
Hi, my name is
All right, and we're back. Welcome back to our second live HaasTec session for the day. We're over here in the demo room. We're over here in the products area again. And before we get started, I want to just say a big thank you to everyone that's joined us online. We're streaming to both YouTube Live and Facebook Live. Had great turnout on both of those platforms. So thank you very much for doing that. So we're starting here today with Milton Ramirez, one of our product specialists. We were hanging out yesterday over on the APLs.
That was fun.
Today, we're going to take a look at the VC400. And this is our vertical pallet, our pallet changing vertical is what we're calling this machine. So maybe just let us start us off on this machine. What are you going to typically use this machine for, do you think?
Well, one of the basic advantages that a customer has when they buy a machine like this is that any programs that they might have for a VF1, VF2, any vertical, basically, they can just transfer over to this machine, no editing, and it should run perfectly.
Right, so you have the advantages of a palletized machine,
exactly,
but you're going to keep all your VMC style programming the same.
Yeah.
That is a big,
yeah,
potentially a big advantage for a shop,
yeah,
that's focused on VMC work.
Yeah, and obviously the pallet changing, capability of having a part running inside of the work envelope and another station where you can load your new parts or different parts or whatever else you want to run on the machine.
Right, just like our HMCs, like an EC400 or whatever, you're keeping the spindle turning while you're loading either new fixturing or new raw blanks or whatever over here.
Yeah, if you have quick change fixturing, you can actually do different setups while the machine is running as well, right? So there's a lot of advantages. This machine could basically run not unattended, but it can run, without stopping at all, as long as it's being loaded.
Right, you're keeping the spindle turning.
Yeah, keeping it loaded.
You want to move to the control,
sure,
and maybe Sal, we can look in the machine here as Milton's talk about some of the features.
Well, as we look inside of the machine, the first thing you're going to see is like a really, a spindle that's pretty common to, I would say 60% of most of the verticals that Haas sells. It's the inline, direct drive spindle. 8100 RPM is standard on this machine. And it has all the cool stuff that we're used to, right? The coolant ring, the nozzles that you can point in all different directions. It has the optional programmable coolant, which is really, really handy. Everybody should have it. And you can get all the
normal options, TSC, P-Cool,
TSC,
all those things.
high pressure coolant, all that good stuff. And the spindle is also cooled, water cooled, right? It runs inside of the spindle head.
Right.
Just like the other ones as well.
Spindle-wise, you can get different options as well, right? You start with standard is 8100 RPM, but then you can step up to
10,000, 12,000, 15,000.
And those higher speed spindles are HSK taper,
is,
right?
12 and 15 only, HSK spindle, so that's also an option. So that's really good to know. Also, you have the side mount tool changer, which we won't get a chance to go see in the back, but it's the standard 30+1 that everybody's getting accustomed to nowadays.
And you can do a 50+1 as well, right? I think.
Yeah, this machine actually has the 50+1 installed on it. It is an option, but the standard one is 30+1. Okay.
So there are big similarities between this machine and the EC400, right?
Yeah, big similarities. It comes with the step column, as we were talking earlier, that gives the machine a little more stability and rigidity when turning or machining heavy cuts.
Right.
Also, the conveyor runs right through the middle of the machine, so all the chips wash down easily, and they get moved out of the way.
Chip wash down and better conveyance out.
Which is really important on any machine. The chip evacuation is always super important, right? And in terms of comparing with the vertical, this is comparable or right between a VF1 and a VF2. So pretty much the work envelope is the size of a VF2, but the travels are the x-axis on this vertical pallet machine is 2 inches more on x-axis than a VF1. So actually it's 22 on X, 16Y, and 20 inches on Z-axis.
Right.
Okay? Cool. Yep. So, and the table is almost the same size of a VS1 as well.
Right.
It's only 4 inches smaller on length, but the width is 14 also, so 14 and a half.
This uses the same kind of hydraulic clamping system that the EC400 does, right?
Yeah, very important. The hydraulic clamping system for the pallet, right? It's going to give it its solid hold when you're machining, and the hydraulics are also used for moving or doing the pallet changes as well.
Okay. Mm-hmm. Do you want to? I know we've got a note on here to take a look at that probe riser. Do you want to just show that off real quick?
Yeah, sure. Yeah, since we have the camera up close over here.
So the probe riser, you can see here, the probe is protected in this little box right here. while it's not deployed, but
exactly. I'm going to have to close the door just to initiate the motion by pressing F2 from the device manager, and you can see it rise.
That's how you do it. You press the button
and then you open it real quick.
The door real quick
exactly.
to see it come up.
So that happens automatically when you're doing, maybe part inspection, or you're probing your tools in the middle of a part just to make sure that it hasn't broken off or whatever. That'll happen automatically. But when you're calibrating your probe, then you do it manually as well. So it's a really cool feature to have. That cover, when it comes down, protects the probe, keeps it clean and free from chips and cooling all the time.
Right.
So let me lower that. Just there it goes down. It gets covered. So the next thing I want to show here is also a standard feature on this machine, and also the EC400. Any palletized machine will have the second home button as standard.
All right.
So what happens is that, let's say you do a tool change, your spindle's going to be way over there by the tool changer arm. The advantage of the second home button is that when I want to change tools out by hand, all I have to do is press this button, and there comes the spindle towards me.
So it's right up front to you now.
So now it's right in front of me, right? That position right there, it's fully programmable. I can position it X, Y, Z axis wherever I want, and then I can just go to my user settings here, and just by pressing F2, record that position, and that's where the second home button will always send the spindle. Okay?
Right.
So again, the advantages are, you can, like we have inside the machine here, we can see that there's two vices side by side. So I can do one op on one, second op on the other, and have a finished part when it comes out. Right? If you want to do more, I mean, there's narrow vices where you can put maybe 3, maybe even 4 vices side by side.
Right.
Because there are some that are designed for that, where you can, put many vices next to each other.
And you could have that. Of course, you could have that doubled over on your other pallet here.
Exactly.
Now we have 2 different setups. We're going to look at that in a minute. You've got 2 vices on one, and you've actually got a 4th axis hooked up on the other side.
Exactly.
But you could have that 2 vice setup replicated out here.
Yeah, the exact same setup. We can have it on the other spindle so that we can run maybe one large batch faster, because we're doing the same thing on 2
You're always
pallets.
swapping one finished and one raw every time you're swapping the pallet.
Exactly. And speaking of pallets, that brings up another point on the control specific to this machine.
Yeah, you want to look at the pallet scheduling system, right?
Exactly, the pallet scheduling system. So let's go here to the control, and I think we're going to switch the view to the control itself so that you guys can see on screen. I'm actually in the current commands page. I'm also in the devices tab. Then I move down towards the mechanisms, where I can control anything, any option that's installed on the machine. And if I move to the right, that's where I can find the pallet schedule table. Right at this point, one really cool thing about this table is that I can associate a program name to the pallet. Let's say pallet 1 will always run program 1003. Right? That means that my operator won't make a mistake. He won't run a different program on this particular pallet, right?
Right. You know that program is associated with that particular work holding and so forth and so on.
Exactly.
You're not going to try to load your small vice part into your rotary table.
Exactly. That would be a disaster.
Yeah.
So the scheduler keeps you from doing that. Also, you can work in probing routines or whatever you want to make sure your work holding is correct, your part is located properly, and all
then within your program, you reference that with an M.
Yeah, by whips. Using whips and the templates from whips, you can program that and edit and add them to your regular program as well.
And is there an M code or something you add to the program to associate it with the
pallet schedule? Yes. If let's say, like we were saying at the beginning, if you transfer a program from any vertical, it's going to have an M30 at the end for the most part, right? So you just have to change that M30 to M299, and then that tells the pallet scheduler, okay, it's a pallet program. I'm going to go and switch to the next pallet if it's ready, right? So that's what I can do here on the scheduler. I'm on the pallet status column. If I press enter, that brings up my choices. I can unschedule the pallet. I can schedule it. I can say it's missing because it's looking forward to the time when this machine can also be ordered with a pallet pool, right? So if I have a pallet pool, if for whatever reason I took out that pallet from the pallet pool, I can say it's completely missing here, and the machine will never look at that station again, right? It'll completely ignore it.
Until you change the state again.
Until you change the status again, right? I can say it's completed, and it would know to put it away, or it would know not to run it. But in this case, pallet 1 is inside the machine, it's loaded, so I can actually just leave it as it is. But pallet number 2, let's pretend somebody already loaded it, it's ready to go. I can schedule it by going here, choosing number 1 and scheduling it. So the pallet now knows that that pallet is ready to go.
Right.
Okay?
So speaking of pallets, I think in a second here, Sal, I think we're going to move
Yeah.
in a moment over to the front and take a look at
Definitely.
the pallet load station. So Sal, you want to follow me over here and
Yeah, I'll let you
then
go
we'll let
first.
Milton come after us here?
So this is what's super cool about a pallet machine, right? Because you have the loading station so that an operator can work on his next job or continuous job while the machine is running, right? That's the major advantage. You're making chips while you're doing something already on a different table or a different particular setup. So it's worth mentioning, as you can see here, that this pallet has a rotary on it. So the machine now is offering a 4th and 5th axis, 1 axis per pallet at the time. And we're looking forward in the future to making it 4th and 5th for each pallet. But that's something that's coming down the line. For now, we can do a rotary on each of the pallets. So really important is that if you do get rotaries on the pallets, then the machine is no longer compatible with the pallet pool.
Right.
Yeah.
You might pull your rotary control cables out of your rotary
are
table.
in the way. That's exactly what the problem is.
But there is also the plans to attach a pallet pool to this machine, right?
Yes.
So then you have the same kind of pallet loading function you have with an EC400.
Exactly the same
all those
particular
benefits
thing.
of
It would
lights
be
out.
the 6+1 pallet pool, right? Okay, so
so there's some things you want to show us with the pallet changer, right?
Yeah, let's say, we always know that, this one, I can't rotate that easily because of that, but it does have a special feature here on the lever that allows me to rotate the pallet.
We can we'll do a pallet change in a minute here, and then we can take a look at the other station.
So, but this machine, it has an arrow, the pallet has an arrow facing you, and it also allows this lever to go all the way up. That means the pallet is in the correct position to be able to do a pallet change.
So it isn't going to lock out here unless it's in the right place.
Yeah, and
so
if
you
it's
know
not
you're
in the right place,
position.
the control knows that too.
Right.
So it will never do a pallet change if it's not in the correct spot. And this is the pallet ready button. Unless this is pushed when the machine is running, then it also will never do a pallet change because it knows that the operator's probably still not ready.
You have to have, I'm assuming you have to have the door closed and press that button.
Yes.
Then it knows it's ready.
That is correct.
Right. So it's not gonna load it if you're here and you have all your tools here and you're still loading your work holding or whatever.
Exactly. It's safe to say that. And also the wash down hose that we have in the front for cleaning the work area, we can also bring that over here and wash down our fixtures, wash down our pallets and the whole area.
Right. Of course,
here,
we have our
in
own
case
air
you
gun
want
here
to
as well.
Have the air gun as well.
Right.
So you want me to do a pallet change
Yeah,
for
let's do a pallet
demonstration
change.
purposes? Okay, let me close that door.
Let you push in there, Sal.
Okay, here we go. Beautiful. So here we are.
Okay, here's our second. So this is an example of having two different style jobs on the machine at the same time. You've got rotary on one side, multi-vices here.
Yeah, and by the way, these are the self-centering Haas vices that will be away soon on HaasTooling.com as well.
There you go. So you want to show us how that how those detents work?
So for setup purposes, for changing parts or whatever it may be, I can rotate this 360 degrees, right? That's not a problem. I can go all the way around as well. But if I stop in the wrong position here, the lever only goes halfway high. It won't go all the way in. So let's see what happens now. Now it goes all the way up.
Right.
So now it triggers a switch. And the machine
So
knows.
there's a switch on that lever, and so the machine knows if it hasn't made the switch, it won't let you do it if this thing's in there cockeyed.
That's correct.
Right.
So, and that's basically it.
Cool. All right. Well, so VC400. This is your pallet changing vertical machine, bringing palletized.
That's right.
Palletized. what do you call it?
Vertical machining.
Yeah,
you know,
bringing
for
a palletized
continuous-
approach to vertical
continuous
machining.
chip making, you know, all day long.
Cool. Thank you, Milton.
Yep, you're welcome.
Now,
Thank
you guys, we're gonna step over to the EC500 over here with Milton. Sorry, with Milton. Oh, I keep saying these things wrong. I think I called you someone else to start with as
Yeah.
well. Maybe I called you Marcus and you Milton.
It was an early morning.
It's not an early morning anymore.
That's true.
All right, so we got Marcus Imes. He's off of the chat answering all your questions, out here to show us the EC500 50 taper, big brother to the EC400 and even the EC500 40 taper, right?
Exactly. So the 500 obviously refers to the 500 millimeter pallet, and 50 taper, it's the big brother to the 40. This is a money-making machine with the heavy-duty spindle and the proven design of the redesigned EC400. So
Right, you've got the same kind of design improvements we had on there. We've got the step column and that sort of thing for more rigidity.
Yep, Milton covered a lot of that. A lot of the base is actually the same between all three machines, and so the stepped column, the improved ribs and casting, the proven 50 taper spindle design from our other machines, all integrated
and part
into
of
this
the
one.
part of the reason we kept it compact like that is to achieve what I guess is one of the smallest footprint EC 50 taper HMCs out there.
Yeah, the footprint for this machine is only slightly larger than the EC400. The tool changer sheet metal's bumped out just a tad, but for the most part, you're getting 50 taper and 500 millimeter capability in almost the same footprint
In a
as an
400 millimeter
EC400.
machine, right.
So you're really not sacrificing space or anything else to get more capability in your shop if you got bigger parts or heavier cuts you need to do.
Right, and we're gonna look at heavy cuts in a second here.
Yeah, just a little size comparison. The EC500 has 10 inches more X and 5 inches more Z, and what that translates to is 22,500 cubic inches of machining area. You compare that to the EC400 is 12,100 cubic inches, so your work zone on this machine is almost twice as big.
Roughly double.
Yeah.
Impressive. So it looks like we got 800 something pounds of pallet on each side.
Yeah, 840 pounds per, or sorry, 880 pounds per pallet, which is a pretty beefy. Is that 400 kilograms?
Yeah.
400 kilograms?
About, I
yeah.
suppose.
But yeah, you can see if you come around the side here, we have a couple big tombstones in there. So this machine was designed with bigger parts, big tombstones.
You want to look at the front side of it now, and then
Yeah.
Okay. Sal, follow us around here and we'll...
If you want to come over, the load station is very similar to the VC400, maybe just a little bit bigger. Yeah, very similar but bigger. You got the pallet ready button, so the spindle never needs to shut down. It'll just keep pallet changing as long as you hit that ready button and reload the pallet. So that's one of the things.
In terms of indexing the pallet, it works similarly, right?
Yeah, same thing here with the index lever. You can get to all sides of the pallet, and you can.
And once
see
again, it's only going to lock out when it's in that safe spot, right?
Yep, and
When
then
the
if you
pallet's
notice,
facing forward.
we have that arrow should point to the operator, and the machine will only start with the pallet in that position, so you can't misload it 180 degrees or something.
Right. So maybe
But
we
yeah,
head back.
You see a lot of common components between all the EC models and the new VC as well.
So now the fourth axis drive on this is brand new, or it's similar to the EC400 in that it's the cycloidal drive now, right?
Yep, we've been having great results from the cycloid drive, and we've now integrated that onto the ECs as well. And so this has the integral fourth axis, so you can get to all four sides of your pallet right there.
Right.
That's a big fan with a lot of high production shops, because now you can hit all six sides of the parts in two setups.
Right.
So obviously,
what you're using an HMC for, part of the reason you're buying an HMC for sure.
Exactly.
And this is so that cycloidal drive maintains the kind of accuracy we had with the earlier worm gear style rotaries, but it is more crash resistant, which everyone can appreciate.
Absolutely. Nobody likes screwing up expensive fourth or fifth axis, and some of them can be kind of delicate. But yeah, we've recently transitioned to the cycloid drive, and we found that is much more resistant to damage after a crash. And I think all production machinists know we're counting our time down till the next one. I mean, we can make that longer, but
That's right.
The hourglass is
May
ticking
happen
at all
some
times.
time, yes. So the spindle on this, the standard spindle is our 7,500 RPM 7,500 RPM 50 taper, of course.
Yep, 30 horsepower standard with gearbox. So
Right.
you still actually have a lot of torque and power from even the 30 horse. Or we have the optional 10,000 RPM upgrade and 60 horsepower upgrade.
Yeah, if you're doing crazy aluminum high-speed hogging or something,
Yeah.
you're gonna probably step up to those and just you're gonna be filling this thing up like that.
Yep, even with this spindle, I've filled up a chip bin pretty darn quick, and you'll see it throw
And
some
that's with
chips.
steel, not even aluminum, of course.
Yeah.
Cool. Well, we're moving. So some of the other standard stuff is the coolant, standard 95-gallon coolant tank, of course, right?
Yep.
It's got the same kind of features as we were talking about on the VC400 and the EC400.
Yep.
Centralized chip evacuation and out to the back.
Yep, better chip evacuation, and just all the updates with the new EC casting design, which has a lot better rib structure and the better chip flow, like you're saying. So you get all those same benefits with this machine as well.
So speaking of rigidity, maybe we should fire this thing up. And see
Yeah,
what we got.
certainly. So if we're Sal here, you see we got a nice sized block of steel in there. We got some Haas tooling in there as well. If haven't looked at HaasTooling.com yet, please check that out.
Yeah, check that out. So we've got an action cam inside here that Frank will cut to now and then. But Sal, I think you probably also want to get in there and look through the window as well.
Yeah, so we'll do a little facing pass here, go around the outside real quick, and then I programmed some real aggressive slots with the Haas 1-inch steel end mill. And we're gonna do 1-inch cutter, 1-inch deep, full slotting, and she purrs beautifully. Taking 100 thou off the top here just to maybe represent slightly uneven
Right.
saw cut or something like that.
So is this Haas tooling tool holder and end mill?
Yeah,
Okay.
Yeah,
Probably a pull stud as well.
yeah. It's
The
easy
whole
to
kit.
order, so
That's right.
that's one advantage to having the tools in-house.
That's right.
But I was really impressed with how the cutter cut. You'll see if you glance at the spindle load when we go to the full slot. I programmed that up to about 120% spindle load, and actually you could run like that all day. You can do 15 minutes at 150% spindle load on our machines. So 120% is an all-day sort of cut, and
Right.
you'll see those chips fly. It makes short work of this block.
If you're at 150% for 15 minutes, that's a boatload of chips right there. That's an impressive program.
I was going to actually ask the YouTube people, if you've ever gotten an alarm for running 150% for more than 15 minutes, I'd love to know what that is, because your cutter inherently comes out of the cut sometimes. So
Yeah.
I want to know how big of a block you have to have that kind of engagement for
Yeah,
that
you're doing
long.
a lot. It's a very heavy roughing cut for a long time on it's got to be a big piece of material.
Yeah.
There we go.
All right, so we're coming over to do the slot here. So if you want to get in there, Sal, it'll throw some nice chips right at the window there.
You're probably going to destroy my action cam in there, I suppose.
Oh, we got it out of the way.
Just below it.
Perfect. Don't have to buy a new
That's all
camera,
right.
Andrew. So
what's
this is
the
a
action cam?
1-inch wide, 1-inch deep, 575 surface feet, 5 thou per flute chip load. And I think I could actually push it harder. Obviously being live, don't want to blow up any tools, but if I was trying to make money off this demo, my guess is I could go 10-20% higher without any problems long term.
I can smell the steel right now.
Yep, we got it's 1018, so just kind of mild medium steel.
Right. And that can potentially be as difficult to cut as a harder one, right? In terms of you've got a high gumminess factor potentially.
Yeah, the gumminess, particularly for drilling and any operation that's sensitive to galling or kind of binding up in the flutes.
Right.
It can actually be.
I know that just having watched and videoed a lot of the Haas tooling test cuts that we were doing, oftentimes you have more difficulty with these gummy materials, even though they're softer. You know, some of the harder steels are much cleaner cutting.
4140 is one of those. I'll
Yeah.
take pre-hard any day. It's so
Right.
much easier at 30, 35 Rockwell than
Right.
the gummy 20s crap.
Right.
Yeah.
So how far are we through here? You're still slotting, right?
Let's see, rough vertical slot. We're getting pretty close to the end here. I put 6 nice slots in there. I'll do a little chamfer pass, clean it all up, and then maybe we'll do a pallet change and bring it over here.
Oh,
You can
cool. Perfect.
check it
Sounds
out.
Good. So that's of course it's obviously a carbide coated end mill of some sort, right? What
Yeah.
coating you have on this one?
Yeah, it's a solid carbide end mill with an ALTIN coating for additional heat resistance and just longer life and higher speed capabilities.
Cool.
Somebody
Alrighty.
in the earlier stream was asking if you can cut stainless steel on our machines. Absolutely. There's very few materials you can't cut.
Yeah.
You get into some of the strange exotics, you know, you might have to add some extra protection for a lot of the
Ceramics and stuff like that.
Yeah.
There are certain things that can destroy your way cover seals and other stuff like that. So
Yeah, but you're
that-
really not limited to any particular materials.
metallically speaking, you're good. You should be good to go.
Yeah.
On anything.
That's mostly just tool path, well, getting the correct tooling and tool path, and you can cut pretty much anything.
Right. Right. Cool. So you want to do a pallet change? We'll take a look at that part. Is it?
Yeah,
are
it's
we done,
just
or-
about done here. Give it a,
Oh, it's doing the chamfering.
30 more seconds.
All right. All right.
My machining instructor said never give him a part that he can cut himself on or he fails you on the spot, and I've carried that through my whole career.
That's great. Then you should be making demos for us to shoot, right?
Yeah, and sit there.
Maybe not just slotting, but yeah.
Yeah.
You don't want to get to a machine and shoot the demo and realize it's got some chips hanging off it or something at the end of it. Come on.
Yeah, nothing worse than that. Alrighty, here we should be just about done. Actually, why don't you zoom in there, Sal? You can see it on the pallet in the machine there if you get a good view of that. So rather than do some pocketing on this, I mean, when you do the low radial engagement tricordial tool paths, you're actually reducing a lot of the tool pressure. And yeah, they look real cool, but that's actually not a terribly difficult cut to do well. A full depth, like a 1 times diameter slot like this is actually testing the machine a lot more in terms of rigidity and horsepower. And if you got anything wrong, you're going to find it out on your first slot.
Right, right. Sounds good to me.
And you can see the pile of chips down there. I mean, so if you can kind of scroll down into the chip pan there, you can see this machine just cranks out those chips.
Like you said, if you're ready to make money, this is the kind of machine you want to do it with.
Yeah, exactly. So,
cool.
Yeah, this is a money maker. If you got bigger parts or need a slightly larger pallet size.
And all in that same smaller footprint.
Yeah.
Yeah, so if maybe you got a little bit of a tight space to try to fit this style of machine into, this may be the one if you're really looking to do some heavy cutting.
Yeah.
So I think that kind of sums it up for what we've got for the EC500, right, Marcus?
Yeah, and if you look,
right.
These chips are still a little toasty. I don't know if you can get a good look at them, but there's some serious chips there. Nice and
Those
blue.
look pretty hot. You're going to burn through your paper there in a second.
Actually feel it. Yeah, those are coming off hot.
Cool. Well, I think we're done with this machine. Brian, you want to step back in here and we'll say goodbye for today?
Thanks, Marcus.
Thank you, guys.
Appreciate
Thanks,
it.
Marcus.
So before we wrap up, I just want to make mention of, we got a lot of different people from all over the world watching. We've got somebody from Belarus, from Ukraine, Canada, India, Indonesia, Germany, and Netherlands. So all over the world.
Yeah, so thank you so much again for joining us, both on YouTube and Facebook. It paid off to stream to Facebook this time. I guess we'll keep doing that.
We have a lot of people on Facebook. We want to mention one more time real quick about the Unlock the Savings promo. We've got a promo running right now. Go to HaasCNC.com, and this week only you get an extra 5% off. So if you're thinking about a machine, looking at a machine, or even just want to build and price one on the website with nobody contacting you, you can do that and you can see the promo
Yeah,
price.
just make sure you get done by Friday, the 18th, because that's where it's going to end. So for tomorrow, we're back at 10 a.m.
9 a.m. 9 a.m. Pacific.
10 a.m. just today for the second
Yes.
one.
9 a.m. Pacific, noon Eastern, and we've got a pretty cool lineup of machines. We're going to start out right off the bat with
Yeah,
you.
probably the machine that a lot of people have been really interested to see. It's kind of a design concept that we just started working on. We didn't start working on it, but it just kind of came to fruition. The VMT 750 is what we call it, and it's our mill turn,
Yep.
as
So-
imagined by Haas Automation.
That's right. So you'll see that at 9 o'clock tomorrow morning. And then after that, we're going to have a couple of different demonstrations on UMC 500s. We're going to do a UMC 500 with an APL, auto parts loader. And then after that,
Yeah, we'll come back.
to you.
Marcus and I, again, will be over on the UMC 500. Wait, yeah, you're on the APL, and I'm on the pallet pool machine.
Right.
And we're also going to talk about MRZP, how that functions on the machine, that sort of thing. So thank you so much for joining us.
Make sure you come back tomorrow, and we'll see you tomorrow at 9 a.m. Pacific.
9 a.m. Pacific.
Thanks, guys.
Thanks.